Yes, Daniel. Yes.
So,
Can you hear me? Yes, Daniel. Can you hear me? Right. Hey, how's the wrist, Daniel? Yes. Uh-oh. How's the wrist, Daniel?
better.
If you think that it will be bad for your wrist, continue. Later you can we're just trying, but in the middle, if you think you have to stop, please tell me. Right? That means there's something perhaps worse than you probably thought lah for your wrist. So don't force it, yeah. Okay. It'll give you a lot of trouble if you don't heal it properly. Okay. Yeah. Is the audio okay? Are you in a noisy environment? Yeah. So because this very rare for you, this time the background noise seems louder than you, but only sometimes. Usually you're totally fine. One.
Go somewhere else.
Yeah. So okay. Tell you what, I'll wear the headset. It'll be easier. Yeah. I think since the your noise cancellation is working very hard, then sometimes your voice a bit mumbling, but it's probably because of the voice cancellation, I think. Yeah. So just help me a bit. Just speak slightly slower. Slower is usually better. Yeah. No need louder. Louder doesn't necessarily mean better, but slightly slower. All right. Give it a try. Yeah. Okay. Right. Okay. So finally found a working vector plotter, right? That will be the replacement to our answer key lah. This way you can see it visually also better, right? Okay, right. So shall we continue from yesterday? Oh. Okay, so plane 3, right? Okay, so do you want to talk about part 4?
Yes.
Okay, let's copy the first plane. Oh, there you go. So tell me first, what is S? S will be 1, right? S will be 1. Then K will be, is it -3/2?
Yeah.
Okay. All right. So is it correct? Okay. 3. Are you sure it's 3?
Yeah,
-3/2. Correct, yeah? Yeah, definitely. I cannot hear you very well. Let me confirm one time. -3/2.
Yep.
Okay. All right. Okay. Then there is the oh, there's this guy. All right. Okay, I think we're fine, right? So I'll focus on P1. I'll do a very short explanation first. So for P1, it will be 2x plus y minus over 2 z over equals to 1. Would this be okay? I'm writing it down in the Cartesian format lah. Would that be okay?
You can express it like that.
You're saying, I'm sorry?
Express it like that.
I cannot hear you. Sorry. Okay, here.
You can express it like that.
Oh yeah, because remember, x, y, z, ma? X, y, z. I'll put it another way. I can express this in a different way. Okay, so r, which is the x, y, z, equals to 2, 1, sorry, not 1, t. T, and then this will be 1, no? And then this will equal to, well, whatever. Okay, would that be okay? So these are very interchangeable and they sometimes do that. Since they do that without warning at all, you have to know. This question becomes a very good revision. This is the only 3 formats you need to know about the plane. The line has 2 and the plane has 3. Again, they will give you no warning what they are using and what you're supposed to do with them. You decide what to do with them. They will also be how to say, they will also be accommodating to you lah, whatever you're using, so to speak lah. Right? Okay, now
How do you find the same form but for P2?
How do they find what? Sorry, same what? Sorry.
P2 in the same form.
T2. I'm sorry, which T2? T, which one? Sorry, T. This one?
P.
This T and this U, right?
P.
P. Which P? Sorry, which P are we talking about?
2.
P2. Oh, wait, but we did already what? The sense, for example, P2. P2's normal is this one, right? We found the normal already. So S is 1. So I'm going to write normal 2 first. Yeah? Normal 2 will be 2, 1, and minus 3 lah. Would that be correct? Now you go and practice. First, if you like, you put it in the dot product form lah. Put it in dot product form, and then from dot product form to this form, it's going to be very easy to do. Please give it a try. You have to have a feel lah. You have no idea what I'm talking about? Yes.
I thought why we dot producting normal.
There. Do you remember that the dot product form is the normal of the plane? Do you remember that? That's always why we want the normal, and it is a very useful thing. The normal and the dot product. They are just so powerful lah, compared to the first form. The first form is terrible lah. This thing is not the best thing to have. This is very good. Like very, very good. Right? So once you have it, and this is the 0, then going from that to the third form, the Cartesian form, is like a peanut lah. It's quite easy lah to do. Right. So I mean that's it lah. That's it, right? Okay. So yeah. So notice that there what's the better way to compare? Let me just draw now. Now once we have this thing, we can start to think, hey, which one are we supposed to use? Which one is the best thing for this question? Sometimes the Cartesian one will be the best because Cartesian has one advantage over the other. Cartesian can be put in the calculator. That's the best thing about Cartesian. There is no other benefits more than that. So I was thinking, should I put this in the calculator? That's why I go to Cartesian and think for a while. I concluded, oh, there isn't. You will see later on, in other cases, putting it to Cartesian and putting it in the calculator will save us so much time, number one. Turns out that that's what they want also. They actually expect you to do that. They expect you to notice when you can put it in the calculator. This question doesn't have any of that, right? So I was thinking, should the calculator help me? No. That's the first thing that I think about, always whether calculator can help me. So after calculator cannot help me, I conclude, then I will go back to my drawing. Look, I like to draw. I feel that it's a kind of the easiest way to find inspiration, right, on what to do. So let's say I realize that my plane 1 will be like that, and my plane 2 to be like that. This is, of course, totally random. I just drawing them. This will be my line intersecting. So far, so good. That's plane 1, plane 2. Yes. So there are only 2 scenarios where P3, so P3, right? P3, sorry, does not have a point in common. So let me show you what that means. Sorry. This is P3, and this is them having a point in common. There you go. The point happens to be aligned, many points. This is the scenario to avoid, if that makes sense. This is the scenario to avoid. Do you understand what we are saying here? If you're avoiding this, then simply avoid that the T and the T and the U, make it so that it will be intersecting in the line. Now, to make it very clear, what are the possible scenarios then? It can be anything other than this one. So it can be like that, for example. See, I'm now intersecting. Nobody, the 3 of them are not intersecting in, the same point. Look at that. I can also do that. I can also do that. I can also. The point is, there are many scenarios where they won't be intersecting in line 1. Okay. So far, so good. Can you imagine that? Right. So I decide to answer them. I think I will comment about T and U not as a value because there are obviously many solutions. I don't think that's what they want. That's why I don't put it in the calculator. I think I'm confirmed that, hey, if I put it in the calculator, usually I'm finding the value, a very specific value. This time, I'm no longer doing that. So this is not part 3. Part 3 is determine the value. I have to do the calculation. Part 4, I am not doing that because there are so many solutions. My comment, I decide, should be so that T and U is not on the line. That's all. That's how I will answer it. Okay, does that make sense so far? That's the I think I finished my thinking and I'll start doing already. Will this be oh dear, there are more than one option. There are definitely more than one option. Right. So as long as L not on what do you call it, P3 as long as that. And to do that is very simple. I'll take the normal of P3, the normal of 3. Therefore, the normal of 3, if I don't want L to be on P3, the normal of P3 shouldn't be actually the easier way. No, I'm sorry. There's an easier way to do it. Okay, I'm going to put it N into the R, yeah? I'm going to put L into the R. So let me just do that. My L is currently there you go. I have your L here. Yeah? So just put this in. And how do I put it in case you're not used to it? But I think you are used to this. So I'll just put 15 over 4 plus lambda minus half, right? I'll put it there. And then this will be 0 plus, well, lambda 1, right? Then this will be 5 over 2, I think. That's plus 0, right? Okay. Now, as long as this dot product is not equal to 0, it's not equal to 0. It's not equal to u. As long as this dot product is not equal to u, L will not be on P3. And that is the only requirement so that, we answer the question. That's it. After this, it's just doing stuff like just a dot product. And I have 3 unknown, 3 equation, that kind of thing. I'm not even sure that we are supposed to solve them, but if I don't think so lah. For 2 marks, I don't think so. As long as this dot product is not equal to u, we are probably fine. Okay, so I'll take, for example, the middle guy lah. The middle guy is lambda times t not equal to u lah, right? Something like that. So for example, as long as lambda not equal to u over t, that's it lah. Okay, that's it for part 4. What do you think?
Hello.
If you're saying something, tell me again.
Is this better?
Can
you hear me?
Slightly better. Slightly better.
Jesus Christ.
Would you ask me again, just more slowly?
All right. Is clear enough?
All right. Yep. So I mean, better, definitely better.
That's great.
Right. Again, do you have a question, or should we move on to the next one?
Let's move on to the next one. Can we do differential equations?
Can we do differentiation? You say, whatever you want to put it on page 5.
Differential equations.
Differential equation will also be a big thing. Would you please put it in page 5?
Yeah. Can you copy them for me?
Let's see. All right, so only the left part, right? Okay, okay, I should be cropping in your work, so let me do that later. Oh, this is probably gonna, sorry, yeah, this is gonna be slow, right? Wait. Oh, goodness me, it's too small. Never mind, let's try that. Can you hear me? Yes?
Yeah.
Okay, I think I'm done. Right, okay. So yeah, sure thing, good. Now, what is your question here? Is it for part A then?
So B.
Okay, did you say B? Sorry.
Yes.
Okay, so your A is done. This is very good, man.
Yeah.
All right. Oh, you did solve it. Let me check one more time. Oh, you did. Yeah. That's nice. What? Oh, wait. What? Okay, so a little bit of modification to your result. Okay, I don't think it's wrong, but there's a preference going on here. So I'll start from here, right? Okay. Oh, no, I'll just start from here instead. Yeah, I'll start from here instead. So this will make it slightly easier, and that's what they prefer also. So let's see, yeah. So this will be x over 1 or minus x, right? Still doing, oh, wow. Will it be wise? No, I think it's wise. I think it's wise to do that, right? Oh, okay, 1 over 10t. Yeah, this is the preference, 1 over 10t plus c. And then I'm going to change the plus c into a times e 1 over 10t. I think in this case, that's better. This is your e to the power of c. Right. Will this help you in any way? I hope. Oh, actually, you never touch it. No, never mind. Sorry, I take my word. In some cases, this is what we want, and other cases, maybe there is no point in doing that. So I'll leave it there first. Sorry, yeah. Right, that's just my habit. Okay. Now, for part 2 then. Find the exact time when the destruction rate is at maximum. Okay. Okay, great. Now, so the dx dt will be the destruction. Okay, right. Okay. Ooh, wow. Okay, understood. Now, what did you do? Oh, sorry. Let me just confirm what you did here. What is this? Can't hear you very well.
The maximum value of t.
Yes, the maximum value of t. And then what happened here? Sorry.
Let's I've forgotten.
Let me see. Yeah, that's problem. All right. Okay, let's just compare that then. Yeah, let's just compare that. Right. So I will choose to start with the original one. 110 x1 minus x, no boundary expanding. No, actually that's easier, right? So when he wants dx dt maximum, he wants that. That's what destruction rate means. That means my d square x dt square. For example, this is the I guess this is the classic one. I want the differentiation of that to be equal to 0. Okay, first one. Then I will do my differentiation. So differentiation left hand side, I do have that. This one, I do have that. And differentiating the right hand side, the 1/10 doesn't really matter. I guess expanding them will be a easier thing to do. So I expand that x minus x squared. There you go. And then differentiating that, x will become dx dt lah, right? Dx dt. And then this will become minus 2x dx dt lah. If this feels a lot like implicit, well, because that's what I'm doing. I am doing an implicit differentiation, and then that will be equal to 0. And at this point, I think this is rather solvable. At this point, should be easier. Now, do you understand what's happened?
Tmax is dy dx.
When I want a maximum dx dt, I simply differentiate one more time and equal to 0. That's the principle, right? This is what we learned back then, first time for finding maximum minimum. Does this make some sense? Because remember the first time you learn maximum minimum, right? For example, I have a graph, a very simple graph, right? Y lah. How do I find this minimum point? Well, I just dy dx equals to 0 because that's where the gradient is 0. That's how I usually go and find maximum and minimum. Differentiate once that guy and equate it to 0. Make sense? I'm just using the same principle here. I want the destruction rate, which is dx dt, to be maximum. I differentiate once that guy and set it to 0 lah. I will be able to find something useful. Does this make any sense?
Why are you doing this?
You mean I shouldn't be doing implicit here, right? I shouldn't be differentiating x into 1. Why am I differentiating x into dx dt? Because I know that x is a function of t. It's not a free lunch thing.
What?
One more time. Isn't x a function of t? There you go. Look, x as a function of t is exactly what you're looking at here. For example, okay, let me put it another way. Usually, this x is what we will call a y. That's what we're used to, right? And usually, this t is what we will call x. That's what we are used to. We're used to the y on the right, on the left, and the x is on the right. Now, it is slightly different. The x is on the left, the t is on the right. So far, so good?
Yeah.
So therefore, I have to treat the x like a y lah. I have to imagine that. I have to imagine, if you like, so that I'm more comfortable in my element, right? I have to imagine that this is actually dy dx, right? Because the y is the x is the t, and then I have to imagine this to be y, 1 minus y. Now, wouldn't you do an implicit here, so to speak lah? Wouldn't you? And that's why I do that lah. There is no free lunch for the x here because the x is no longer the x that we're used to, so to speak. Right? Still, that doesn't mean that things are going to be hard. The moment I do this, I realize, oh wait, wow, doing that is probably not going to be a very hard thing lah. At least that's what I hope, right? Now, can you continue from here? See what happened lah.
All right. X equals half.
Sorry, where are you doing it? In the Jamboard? Yes? Or in your... Okay, right.
So how we solve for T?
Yep, just use your original equation. That's how you do it. That's it. Make sure that I did it correct. Yeah, correct. Yeah, minus, yeah. Yeah, I think I did the differentiation correct. Oh, wait. There's one more thing missing. So this can also be dx over dt equals to 0, right? Very weirdly. So, and then using the original dx dt, I will be able to find whether the x is 0 or when the x is 1. So I have 3 answers here. Right. So far, so good first. I have 3 answers, and maybe one of them is maximum, maybe 2, maybe 3. I doubt that there's 3 lah. Maybe one of them is maximum, maybe one of them is minimum. Maybe.
So I sub. How do I sub in X equals to?
We have to find out which one's maximum first, right? And according to the equation, he just won 1 time.
Safe to assume X equals something the maximum. This is what they make us find.
Oh, goodness me. That's why he wants you to plot the graph. That's why that will make it so easier to find out which one. The first part, sketch the part of the curve. Once you sketch the curve, it's usually very obvious which one is maximum and minimum. Why don't we do that? Why don't we welcome his help lah?
How?
You have a graphing calculator, right? Graphing calculator should be your definite cheat sheet lah. If you just put it in the calculator, you can plot it.
I don't have it with me.
Then you would just wait. Oh, no. Why don't we just use Desmos to solve our problem here? Okay, please confirm that I'm typing the right thing. Yeah? So I have to use Y and X, by the way, here. I have. So swap it up a bit. This is going to be e to the power of x divided by 0, right? Okay, right, this one. And then this will be plus, oh, sorry. This will be our plus c, right? Let's add a slider for now. Okay. And then this will be divided. Okay, 1 plus that. So if you do that in the calculator, oh wow, that's a weird. That's a weird one. Okay, did I type correctly?
Are you drawing something?
Do you look at my screen sharing?
Oh wait, so I noticed. Yes.
Probably I go to 0. And then I'll go to 10. Yeah, 10 is too big.
40 is greater or equal to 0. So I don't need less than 0.
Right, there you go. Okay, so that one. So just focusing on this. Oh, turns out the graph is very simple looking. Correct, yeah? I did set the c equals to 1. So annotate, sorry, let me annotate for a while. So by setting the c equals to 1, I have to find out what the graph actually means in terms of c. I cannot just cheat and say c equals to 1. So I'm guessing that this will be my c lah. I'm guessing lah. So the graph will kind of just asymptote at c. So I'm gonna change. I'm gonna test my theory for a while by simply changing my c. Oh, it is not. Wow, it is not. Turns out that every time I change the c, it will always asymptote at 1. That's so convenient for me, right? I'm quite happy to do that. Okay, so this is not c lah. C is something else, and let's say I'm not going to bother about it first for now because the graph is so easy to understand. Okay, so far so good. Make sense? Okay, so did he say anything about the C? Let me check for a while. No, the C comes from the constant. Wait, let me think for a while. Maybe we'll. No, it doesn't tell us anything about C. So I'm going to go to the next. I'm sorry, go to Desmos again. Right. Now we have a graph of yx or xt. So when the destruction rate is maximum is when my dx dt is maximum lah, right? This is a xt graph. So first I'll help myself by visualizing the gradient first. Gradient is like that, like that, like that, and finally like that. I'll call this a very big positive into a smaller positive into a very small positive until finally it reaches 0 lah. Okay, I hope this makes sense. So I'll say that my dx dt is bigger the more I go to the left. My dx dt is bigger on the leftmost side because I see the dx dt reducing in the graph. So this should be my dx dt maximum. If I have three answers, x equals to 0, x equals to half, and equals to 1, I will choose x equals to 0 as the answer. Looks like there, the gradient is the steepest. And that will be my answer. Would that make some sense?
Still does not answer the question. Where do I sub it in?
You still have to sub it in, but I will just sub it equals to 0. The original. You have to find the t, right? Correct?
It's original.
Yeah, I mean, where else would you sub it in if you want to find t, right?
Oh, we're talking about very blur.
Yes, you are very blurred.
So I sub it into dx dt equals 1/10 x.
No, it won't work because there's no t there, right? So obviously, no, let's not do that. Let's not sub in the differentiation of that also. Let's just sub in the
hard work.
Yeah, the hard work that you did You did a very good hard work, what? Right? That was your original plan, and there was a good plan.
D plus 1 C is 1.
Okay, sorry, let me clear up my drawing. Yep. Okay, so where are you doing? Oh, you're doing it there. Okay, wonderful, nice. Hey, wait, where are you doing it?
Page 5.
Page 5. Okay, I'll just wait for it to pop up. Yeah, but I have to wait for it to pop up. Yeah, so in time.
On 1, 2, 1. Wait, what? Can you not see it?
Not yet. I'm just waiting. Yeah, okay, maybe. Yeah, no. What? Okay. Oh, long.
This 1, 0 equals 2 equals 3. 2 equals -10.
That's very weird.
Just not doing different.
Okay. Let me read the question one more time, just to make sure that we didn't miss anything. Yeah, nice, okay. Okay, right. Instead of, oh yeah. No, let's say your answer doesn't seem to make sense, but it makes a lot of sense. This -10. Let's say your answer is correct first, right? -10 makes a lot of sense. This is -10 hour, I think, yeah, -10 hours. Because that means the dx dt is the biggest 10 hours before it is noticed. 10 hours before it is noticed. There you go. Okay, so t is hour measured from the instant the fire is first noticed. Usually we will reject such a time, but this case makes a lot of sense, I would say.
Are you writing something?
No, I'm just highlighting a phrase that we should pay attention to. The phrase will be this one. Right. If you look at the oh, okay, that's a bad idea. If you look at the screenshot, I think that's the screen sharing is just easier, right? There. Yeah. I like your answer. Your answer means that it's already the biggest before we notice it. Let me just check whether there's a mistake or not. Yeah. No. Looks good. I mean, everything looks good. Yeah, everything looks good.
Well, the answer is like ln 4. Something.
The answer is ln 4. Wait, check for a while.
So it's 10 ln 4. So
oh, goodness me.
So ln 4.
Let me check one more time. Again, is there a mistake? Okay, please confirm that if you have the answer key, please confirm that your function is correct first. That will make it easier.
What function?
Your hard work in your hard work in part 1 should be correct first lah. Then we have less doubt, right? Wonderful. No, we don't need this, but it doesn't matter. It's correct or not correct? Sorry.
There's an A.
The A is what I did, lo. The A is what no, there's no confusion there. That doesn't mean it's wrong. Let me just show you what they did. That's their preference lah. There's a preference in the
A keeps on going.
Right. So let me try to do the A for you, right? Let me try to do the A for you. I'm gonna stop sharing for a while. It's a bit heavy. Okay. Correct. They go and find the A. Correct. They go and find the C and the A, which is not what we did lah. We didn't do that. So let's see. So we are missing something here. There you go. This is what we're missing. This thing lah. This phrase is initially noticed when it's destroyed. So this means initially noticed T equals to 0, right? And then 20% of the total area of the forest is destroyed, means this is now X. X is what? The total, okay. X means it is 20% or 0.2. Put this in, you will be able to find your C. The proportion of the total area which has been destroyed is, okay. Put this in and you'll be able to find the C. The faster, the better. For example, you will find it here. Go and find the C here. Right. So that's what that's what missing from your work in part 1. Do you understand? Finding the C lah. When you find the C, you should get the answer key. Yeah. At this point, I think we should change page here. Now, are you finding the C, Daniel?
No.
Okay. Yeah, all correct. That's y equals to 1 minus there you go. There you go, nice. Yep, it's much better. Yeah.
Where you at? What page are you
I'm still at page 5 waiting for your C lah. Right.
on? Okay.
Yeah, I have a new graph and that new graph is definitely better. Yeah, because we don't have to guess the C. Good.
The C is 1.
C is, sorry, C is?
C is 1.
Then can we get to the answer key lah, right? If C is 1. Oh, sorry.
Let me see if I can find the answer key for you.
Yeah, because I cannot see anything that you're writing right now, right?
You put that A, which is equal to plus minus e to the power of C, is 1/4.
I guess you can go and find the A. Yes, right. So, this is what I told you about that.
Yeah.
This is what I told you about the habit. So what is the habit that I'm talking about? Like this. So when they encounter the C above, they seem to hate it. They seem to hate plus C above. Instead, they prefer to rewrite it as like this, where the A is actually your e to the power of C. So this is their preference. I'm telling you so that you can follow the answer key better. Does this make some sense so far? I'm writing something there. In page 5.
I see nothing.
Right. If you could go in and go out, that's just the iPad thingy. Or rather, I should just share screen again, right? When we're about stuff, we can. I should just share screen again. Right? This thing, I'm doing their habit, hating the C and preferring it to be like that. You see that? Okay, so that's what they prefer lah. They prefer A instead of e to the power of C. As for the 1/4, that is what you get, I believe, when you put in the 0.2 here lah. When you put 0.2 here, you will get your 1/4. From there on, well, it should be a easy way lah to the final answer. There you go. Does this make any sense? Yeah, this one need to make sense. This one, if you don't, it doesn't make sense. Please tell me. This is like what they want to do every time in differential equation. They hate the C, they want the A. They were going to ask you what's the A in some other questions. They really, really want this. To be fair, it makes certain things easier lah. It does. To be fair. To make space, can I erase your work for a while? Or rather, maybe I'll just move it lah. I'll just move it for now in case you need to look at it later. I'll move this here. That's your work. Okay, so one more time. I'm using the information that we are missing t equals to 0, 0.2. So I'm just going to put it here, 0.2 over 0.8, which very conveniently is your 1 over 4 equals to a. Why? Because this is e 0. So this one is going to be 1. There's my a. A is 1 over 4. Okay. First thing first. Clear first? I found my a. Life should be easier after this, I suppose. Okay. I'll just continue from there. Right, so now once I have the a, then I will actually just do the same thing, I guess. I'll just go back to the original equation. Now I have this, e, with a slightly easier thing to manipulate. Then I will just do I'll just do the normal thing. I'll just do 4x equals to, 1, I'll just do E10 minus x E10, right? And then at this point, I think if you manipulate, you will get the answer key. Will this be okay?
Yep.
All right. Okay. So are you okay with part 1 and are you okay with part 2? Part 2 should now be correct because of this. You just have to sub in the x equals to half, right? Yep.
Okay.
All right, part 1, part 2 is done. Part 3, do we discuss?
Explain why this cannot be used as because time starts at 0.
Fair enough.
You can't really estimate the negative time. Yes, I don't know. I'm just throwing out ideas.
Let me think. Let me think carefully. I think. Okay. Let me just show you the decimals for a while. This is what they mean. Okay. You're not gonna ignore the red one. The red one is the original one. The green one. Right. So look at that for a while. I'll just pick from the model, right? I'll just pick from the model. Look at that. When the fire start burning, it should be when the y is 0. Remember, y is the amount of what do you call it? Amount of forest kena burn. 0 means not yet burning, but gonna start lah. The y is at 0 is the start of the burn. So far so good. Can? The y that I'm talking about is the x lah. Now look at this graph. Look at the function that we have right now. Where is y equals to 0? It's infinity minus lah. Correct or not? It's way at the end. If that makes some sense. That's what the graph is giving you. Correct or not? That's just how the graph looks like lah, if you put it in your GC. Mathematically, this is why the model cannot estimate when, because the when here is the x-axis. The x-axis is minus infinity. We can't. I think I will stick my comment to there, just looking at the shape of the graph. I think that's the safest thing for 1 month, if that makes some sense.
So there's no minus t.
So I'll say something like this. When x is 0, t is minus infinity. This model cannot handle that.
So
because
there
obviously
is no real value of t.
Yeah, when it starts to burn, right? When it starts to burn, hey, how do you mean by when it starts to burn is minus infinity? Then how long has it been burning infinity? Does it make sense? What, something like that. Okay, the formalities will look like I have to move to the next page. Okay, very crowded already. Okay, again, I'm pasting the graph so that you know where this comes from. If you notice already, the sketch is very important. To me, it has always been important. I feel that that will be a great benefit to you when doing this kind of thing. So x is 0. Just to remind you, the x is the y-axis and t will be the x-axis. T equals to minus infinity. So therefore, forest has been burning. The conclusion doesn't make sense. Right. Therefore, the model is invalid. Something like that. For the explanation, I will actually draw the graph. Right. All right. If you're okay with that, would you like to move on to part B?
Shall we move to B?
Yeah, of course. Yeah, that's what I asked. Just yeah.
So I didn't hear you.
Oh, okay, right. So dxdt. Then he proposed a second model to find the actual thing, right? The for A3 cannot use this one. Let's use this one. Any idea how to proceed?
So do you see any ideas on what to do?
Yeah. Any ideas how to start? Yes.
This is determine how long the fires has been burning. The fires first notice. T is when the fire is first noticed.
How long the fire has been burning, right? So when it is first noticed, remember that this is t equals to 0, x equals to 0.2, right? I would think that how long the fire has been burning. That means, first of all, we start from x equals to 0. Lo. That's the start of the burning. Ma.
Yeah.
And I will find that t equals to I don't know where, and t equals to something, which should be a negative value. Lah. And this will tell me how long the fire is burning.
Oh, so I solve for x equals 0.
Yep, I have to sub in x equals to 0. That's my thinking lah. My thinking right now. I've never seen this question before. That's what I'm thinking. But how do I do that? Oh goodness me! I have to again, find x as a function of t lah. I will have to do that. If not, I cannot do that lah. If that makes sense. So I have to find x function of t again. That's where it's just the same as the first part, right? I have to find this. Can I find this here? Is this easy to do or difficult to do? Put it another way, is this a differential equation, which is what your topic is at? Is it a differential equation or is it a normal equation? Usually we will like a normal equation. The differential equation is a hassle, right? It's a bit long lah to do. Can you tell whether this is differential or normal?
It looks normal to me.
And if this is normal, you don't have to use the differential technique. You can, for example, integrate. You cannot integrate the differential one. That's why you can integrate after you reorganize stuff lah. You can. That's what. Do you have to reorganize this, or can we just integrate directly? That's the thinking process there. Gonna have you compare with the first one, right? Gonna have you compare with the first one.
I think if I wait.
Yeah. How do I know and how do you know? Come, let's be quick in that, right? Okay. How do I know and how do you know? Right? Nothing complicated. Good news, right? Now look at this for a while. Remember that we're confused with the x. I acknowledge that all the time. Everybody is confused with the x. I am going to make my life easier and look at this. This is dy dx, right? So therefore, this is my y and this is my y. This is for my thinking. Okay. dy dx equals to y something. This is where I know immediately this is going to be differential equation. I have to do something before I integrate. You understand? The mark is that there is a y on the right hand side, which is not normal at all for any differentiation question. It's not normal. That's why we go through a lot of trouble to solve this one. Okay, that's the original one. Look at the new guy. The new guy is, again, to prevent confusion, I'm going to change this to dy dx. And this is x. Did I miss anything else regarding the x and the y for the new guy? Did I miss anything? Any x or any y to convert?
I'm sorry, I can't see anything.
Would you go to the screen sharing? I screen sharing so that it's faster. Oh goodness me! Right. Oh wow. Okay. Right. Okay. So one more time, the original one to prevent confusion, dy dx. I noticed that the right hand side has y and y. That's why I have to do differential equation. Just more mafan. The new guy, I change it to dy dx and I change this guy to x. Look. Did I miss anything else here? All right, so look at this. The right hand side only have x. The original, the right hand side have y. Very mafan. The new one don't have y. Should I go through differential equation method or can I just integrate this therefore?
So more like 5 times, man.
Yep, 5 pi, plus 1, but those things are constant, right? So to speak, those things are constant.
You don't need to do differential.
You don't need to, yes. Correct, you don't need to.
Yeah,
correct.
Amazing.
Correct.
Let's get on with it then.
So, do you know how to do it?
No.
This is your normal differentiation.
I mean, I can try,
Okay.
but I don't want to.
Right. Okay. All right. Okay. So I'm getting rid of the. I'm sorry. This is dy. This is still dy dx dt. So I still have to write this as dx dt, right? I'm getting rid of the 1 over 5 pi, right? So that it doesn't bother my thinking, right? Getting rid of it, and then I'm rewriting it as this lah, right? So 1 plus something square, and the something square will be an x over 10. You know, I'm sorry, that's a t. Sorry, t. Oh. Right. Plus a tangent pi over 10. I am going to change this to c for a while so that it doesn't confuse me. This is a constant. The c is equals to tangent pi over 10. There you go. Right. So this is a constant. I only have to worry about this lah, so to speak. Now, I'll try to jog your memory here. Is there any form of integration that you can, use or help yourself if it's 1 over 1 plus something square? There must be something here to help you, right? Do you remember? That's your differentiation. Some format is helping you here. The format that you are looking for is the 1 over 1 plus square, something like that. Whether your data booklet lah or what, remember something. Come on, remember something. There's something here to help you one. I think they have it in the data booklet.
For the what?
For integration. If you look at your data booklet, I think there's something there to help you.
The one over.
Yeah, the something that you're looking for is something like this: dy dx equals to something like this. Function of x, maybe something like that. Should be like that.
Is there a square root? No, right? It's all square.
Not the square root one, but there's one with the square one. Definitely there's one with the square one.
Yeah,
it's gonna be tangent inverse thingy. Come on, it's gonna be a tangent inverse thingy. Yeah.
No, the integrated result is a tangent inverse.
Yes, precisely. And see, it's in the data booklet. It's in the data booklet, is what I'm trying to say. I'm sorry for revising with you, but you need this one. It's good for revision anyway, right? So you write that down here first. You write down what it's supposed to help you, and we work it out together. Because if you cannot even realize it, then we are just on dead end lah. Cannot lah. Write down first. Write down what you see in the data booklet. You find something important there. You found something good. Nice, very good. Yes, something like that. Yes, nice. Okay, now let's stop and use this. This is like super good, right? So I'm gonna erase mine here. Okay, so look at this.
So we have. Can I just ask a question?
Yes, please, of course.
Okay, this one. This is the dy dx.
Which one? Yeah, we think of it as the dy dx. Yes, not dx. This is very confusing. This will be that, because if we integrate that, you will get this, which is what we want, right? We want so that. We start from here. Yes.
The other side will be 1 because we integrate a dy dx. Oh no, but it will be x. You get x and we integrate.
Yeah, you get we get y. So in this case, x, right? Which is very confusing for us. Fair enough.
So
very enough.
y
very
equals,
Stop. We are not.
A-
Stop. We have to do something first. Stop.
A-
Stop.
With the
Stop.
convert lah. Isn't this
Yeah.
converted already?
Stop.
We got it here.
Stop. We are almost done. Stop. We have to identify the A and the fx first. Sorry. We have to identify the A, the fx, and the f prime x. Furthermore, we need the f prime x. That's the requirement here. So what is the
1.
fx? So let's just be clear. The A is 1. Fair enough. That's correct. That's the easy one. That's easy. This is A equals to 1, right? Great. A squared, right? Same thing lah. This will be your fx. Again, very easy, right? However, I need this to be f prime x, which is f prime x is not 1. I need this to be f prime x. There's no problem here, but you have to do something. You tell me what's f prime x right now? Very easy. If this is fx, this needs to be f prime x. Tell me what's f prime. Again, to prevent confusion, this will be y, this will be x, okay? You cannot run from this, yeah? You cannot.
So confused.
Yeah, you are. You are very confused. I know. Your foundation is just not solid. But this is your fx. Just tell me what's f prime x, the differentiation of this one. It's very easy. See, I changed everything to y and x already. Easy for you.
So difference will be 1/10.
Correct. No, 1/10. The c, the constant is gone. The constant is gone.
You have to differentiate tangent.
Yeah, tangent pi over 10 is a number. It's a number. Come on, man. Tangent pi over 10 is a number.
Oh, that's pi. I thought it's t.
Well, read better lah. Read better lo.
Okay. Sorry.
Read better lah.
Yeah,
Right? So it's 1/10, right? 1/10. Now, which means I need 1/10 here. I have 1. Is that a problem or not?
No.
So modify so that you have 1/10, then you can carry out. You can carry out whatever this whole thing is. You can.
So you times 10 on the outside.
Yes, very nice. Very good. You know that. Yes, very good. So this will be 10 and this will be 1/10, no? Right? Happy, lo? Now you can integrate.
Yes.
Now you can integrate.
Astounding. Let's see. Let's do this. So it will be 2/pi. Integrate.
Nice. Yep.
10.
Integrate that lah.
Verse 1.
Oh no. That's already the result of integration. What are you talking about? This is already the result of integration. Stop integrating, right?
Sorry.
Yeah. Okay.
Sorry. Brain lag. So it'll be 10 tangent 1, tangent inverse.
Yeah. And then the
fx
fx will be
t/10.
T/10, nice. Yep, T/10.
Plus tangent pi over 10.
10, yeah, nothing changing. And then over A, which is 1.
Over
1. A is A. Wait, A is
1.
A is
No, it's not. A is
1. So this one is wrong. A is 1, right? This one's wrong.
No, A is 1/10.
Since when is A 1/10? You tell me again.
Wait, that was 1/10. Oh, f inverse x is 1/10.
Yes.
Yeah.
A is 1.
Yes.
A is 1.
A is 1.
Yeah. Look at this. Look at the position. This
You're
is
right. You're right.
yeah,
Yes.
hello. Yes. I mean, I can
Okay,
force
right.
it to be something else, but I don't need to. I don't need to. That's fine. Yeah, we're happy with this. Right, which is a very nice thing, right? Okay, we have this. We have this nice thing, right?
Okay.
Okay,
So we found that.
and
Okay,
we can
Amazing.
just put it in. This is x equals to blah 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 t, right? Nice. So back to the original thing, lo. The original thing is to find this lah. This one is the original question lah. When x equals to 0, what is t?
So then we sub in x equals 0, then just solve for t. Yeah.
Yep, solve for t, and then you should have the answer lah.
Okay.
Okay.
So x equals 2/pi.
Oh, better erase that. Yeah, no need. Oh, we're going to no, so
Minus 1.
erase that.
T/10. Whoa! Why am I on page 7? What the?
No, you're in page 6. You're in page 6.
I'm in page 6. Yes, I am. Okay. Plus tangent 5/10. All right. So I let x equals 0. Right. So I can just divide everything by 2 pi. Therefore, tangent minus 1 c/10 plus tangent pi/10 was 0. Is this fair to say? Yes, it is.
Nice,
um,
nice, nice, very
so
nice.
I have to get rid of this tangent inverse
By simply asking when is tangent 0, right?
tangent
Okay.
inverse.
If a graph like where is it at 0, right? So that's a tangent graph, lah,
0.
right?
So I
It's
let
a
it equal
tangent
0.
graph. Yeah.
Equals
So yeah, the inside is equal is
c
0 also lah.
over
Then
10
equals
minus tangent pi/10.
pi over 10, yeah,
all
pi over 10, and then times
equal
10, and I guess whatever that number is, that will be the number lah, which is minus, which is exactly where we can actually, we don't know whether, oh, it is minus. Okay, so whatever that number is, that number will be correct.
Okay, got it. So
Got
then
it,
I
got it.
just slap it into a.
You just say that
Do I need to
because
find exact value? No, right? I don't think so.
I don't think I'm interested in that, but I guess we
Yeah.
can. At this point, I'm very happy already. Do I convert from exact to non-exact? I don't know. I have no idea. I just answer this way. I'll just answer it this way. I have no idea what your teacher likes. But yeah, something like that. So it turns out we have a bonus here for normal integration, right? Okay, now my advice stays, the dx dt is very confusing for our brain one. If you want to, you change it to dy dx for your benefit for a while. Then you can think more clearly. If not, your brain is fighting against you, so to speak, which is not what we want. Okay, that's one of the practical advice. We still have half an hour. Are we moving to the next question?
I haven't eaten in like 18 hours. Can I get some food?
Please. Oh, please. You are always allowed to eat something. Always. Please do. Right.
I will disappear for 5 minutes. I'll just get something. I'll come back.
All right. Sure thing.
All right. Thank you. Hello.
Yes, here. Yes, yes.
Okay, I'm back.
Yeah, you can eat your stuff while doing this. No problem. Okay. Now, do tell us what is the next question.
Any questions? Page 7.
Okay, I'm just waiting for it. Yep.
Sorry, you're gonna have to pop it again because.
Yep. Okay, this one will take a bit slow, yeah.
Yeah.
Oh, let me do that. Okay. Wait. What? Okay. Tell you what. It will be because the question here is very small because of the half thingy. Wait. Now this one I can. Okay. Good. No complaint. Next time, don't make it into a split first. You make it into a perfect screen. Just one screen. You crop it and then you go back to your half. Would that be okay?
Okay.
Right. You'll make it easier. Right. So this is
for some reason on my iPad, whenever I screenshot, there's an option to crop. So the crop function doesn't really work.
Right. Which is a bit weird with iPad. Right. Never mind. Okay, I'm not the expert here. But don't half screen when you screenshot. Yeah. Okay. Now look at this. So look at this. I mean, he did already say differential equation now. So you know that it is, no, actually, no. No, actually, I'm pretty sure that this does not require. Okay, I have the same question, I guess. Yeah, I have the same question. Oh yeah, you integrate directly. Good. So you don't do a differential thingy, right? Okay, the reason is because this is y, right? That's all x's and we don't see any y on the right hand side. Now,
yeah.
The question is now a simple integration. Can you actually integrate? The way you integrate is probably not the right way to do it. Okay, right. So you got rid of the 5√5 and you don't care about the -5. So the question is there anything in your data booklet that is supposed to help you with the square root thingy? I think you saw it just now, I have a strong feeling that you saw something like that just now. The one with the square root in the bottom. Come on, your data booklet, please. Focus on this one. You do have to find this quick during exam. You have to suspect that the data booklet is helping you.
Yeah, found it.
Yep. Write something here and then you do that. And you do that. That would usually solve all problems.
All right.
Okay, rewriting that is such a good idea, right? Such a good idea, and you have to figure out the f prime later, right? The -1 cannot lay. The -1 doesn't fit here, lay. Cannot lay. Really no. Cannot.
Yeah.
It's not. No, not that one. Not that one. There is a 1 with a plus. There is.
Nope.
Oh.
There's one that's not square root.
Oh, wait. Oh, wow. No, you're correct. No, correct. Let me show you what we're supposed to do. No, let me show you what we're supposed to do. So let me confirm that there is nothing in the booklet that is like super similar lah, including the plus, square root and plus, and the square some more, right? All those weird stuff. Okay. Okay, now I'm gonna deal with it lah. I'm gonna deal with it. 5. So now we go back to our so I'm going to call this fx instead. So I'm going to call this whole thing fx. Right? Okay. So now let's be very clear. If I call that fx, what is f prime x? Quite easy.
2x.
2x, which is very similar to the one on top. So I'm gonna do that thing, right? I'm gonna do that adjustment thingy, right? 2x over 2. Okay. Sorry, let me just put that in different colors. 2x over 2. So now this is going to be my f prime x lah now. Happy, right? Okay, yeah. So now, before I do it, does your data booklet say anything about integrating f prime x over fx? If not, then I'll just do it for you.
Okay. Integrating over f prime x.
No. Integrating f prime x on top, right? Here, over fx lah. The bottom one is the fx. Right? Okay. So this is simpler.
Yes, it will be non-fx.
So, wonderful. So we can use that here. Yes, we can.
Oh, wait, yeah, I didn't see that. Okay, I get it. Good.
So now you know that this one is not suitable, but it will be suitable next time, right? You know, in another question, right? Okay, just so that you can be agile there, right? So you do that.
Keep it in mind.
Oh, you should. You really should. You really should.
I feel a lot better after eating.
Which is actually, I will argue that you should just eat at the start. Yeah, you should. At 12. Right? Nobody can think about math while being hungry. Right? Nobody lah, nobody. Right. Give it a try. Give it a try.
Yeah, wait a minute. Let's just throw the square root again.
Oh.
Sorry.
Sorry. I made that too easy, isn't it? Right. Sorry. Yeah. There should be a half. Nice. So now. Oh wait.
No, it doesn't work anymore.
No. Wait. Let me think for. Wait. Let me think for a while. No, it's fine. I think it's fine. Look at this for a while. Look at this for. So it's not this one. Sorry, that was my mistake. But it still works. Right? It still works in a different way, lah. So this will be f half, lah. Right? Half. This one is wrong. I know that's because of me, but still it will work. Now let me show you something. For a while, so that you understand. Now once I have this and this, once I have this and this is very similar. The logic is very similar to integrating 1 over x half. Now, you humor me for a while, and try integrating this. Of course, this looks simpler, right? Over half, which is 2, right? Right? Okay. Which is equal to 2x half, right? Okay, good. Right. Something like that. So now, if I'm correct, if I'm not bluffing, then if I do that the same thing here, then I will get an answer and I can test the answer by differentiating it back. Okay. I'm not supposed to bluff you. I'm supposed to show you that this is correct, right? So now I'm saying that this should be something like fx. It should be like 2 fx square root, right? That should be the result of the integration, which is to say this will be 2 square root x square plus 4. Okay, would this be okay? That is what I think the integration should be. Now I'm going to differentiate this back so that you see for yourself whether I'm correct or not. So now differentiating 2 x squared plus 4. Right? Okay, what is this? So this should be, I'm sorry, it'll be easier if I just make this into half, right? Just easier that way. There you go. Yeah, this is just not easier. Right? Okay, so now the differentiation of that will be 2, again ignored. So it will be x squared plus 4 negative half, right? Correct? First thing first lah. Will this be okay?
Yep.
Times half because of the root. And then times 2x lah. Okay, am I okay so far? This is simple differentiation. Can? Then result will be 2x x squared plus 4 half lah below. The result of the differentiation is my original thing lah. So my integration must have been correct. Do you understand what I have just did here? Unless I differentiate wrongly and I'm bluffing you. Look at this. The way I differentiate, is it correct or not?
Yeah, no, yes.
So you have to be able to integrate it this way. I'm not sure whether you are seeing this. Do you see it the way I integrate? I see this as this, I integrate. So I'm just integrating this way and I prove it to myself that I'm correct. This is kind of like expected from you. Like, yeah, I would say, yep, definitely. Yep. If you have some doubts, you please ask me right now.
Yeah. Okay.
You hear him? All right. Then you still have to handle this thing, right? You still have to put this in. You still have to integrate -5, very easy. And don't forget there's also a constant. Don't forget. You already know all that. So just put it in first, everything.
I squared 5 over 2 times 2x, x squared plus 4.
If you're writing somewhere, you tell me. Page 7, is it?
Yeah.
Okay. Okay.
Minus 5x. Open bracket. Suppose like
Plus yeah, so I think this thing belongs here, not here, right? Would that be okay? And there's a simplification there, and then you forget the plus C also. Would that be okay? Okay. Now, here's the question. They ask you to solve lah. Does solving mean I have to find C? Sometimes yes, sometimes no. Definitely yes, definitely no. Do I have to solve for C or not? If that's what they ask.
you can ask for it.
I have a strong feeling that we need it, whether they ask for or not. I have a strong feeling that you will be needing it. Because of part 2. Part 2, he asks you for minimum time, right? Okay, let's pretend for now that we don't, because I see a lot of ways to solve the C also, right? So let's pretend for now that we don't solve for C. Let's see what happened in part 2. We can always come back one. In exam, sometimes we do that. Hey, I never even thought about the C, right? However, the part 2 will force you to do it, and you just do it. There's no harm in doing that. Now, next page, I think better, yeah? So next page. What would you do to do part 2? Part 2 shouldn't be, hopefully, that complicated. Okay, page 8, yeah? They ask you for minimum time. Oh, wait, this is not going to be, this is going to be hopefully obvious. Because minimum, maximum, there's a very simple principle to apply, right? Page 8. Okay. Shall we do it together on page 8, Daniel?
Okay.
Right. So to prevent our confusion, this will be our y, okay? This will be our y. So he asked for minimum y lah. Right? Minimum y. Oh, it's given. Oh, now we are finding the C in part 2. Oh, now I'm sure. Okay. So given that the minimum time, right? So now anything with minimum should be treated with dy dx. So since he wants y minimum, I go for dy dx lah. equals to 0. Okay, I go for that. Right, so at this point, I'm going to do something with dy dx equals to 0, which is this one, right? Okay, so therefore, 5 root 5x, or this one, minus 5 equals to 0. And then I will just equate this to 5. Right, and then I will just cancel this and cancel that. Right, so now I will have root 5, sorry. Root 5x equals to the 4 square, and then I can probably solve it. Would you take it from here? Are you doing something on page 8?
So you equate them to each other. Therefore, square root 5x all things squared is equal to square root x is 4 things squared.
Yeah, I mean, I'm not seeing. Oh, there you go. Okay.
Squared plus 4.
Yeah, then this should be easy to.
4, x squared equals 1.
So it's a plus minus 1 lah. At this point, maybe the minus should be rejected lah. So what does this mean lah? So what does this mean lah? Okay, so minus 1 reject, right? Because I don't think in this situation it makes sense. In the previous question, it makes sense. Be very careful, yeah? Be very careful in rejecting minus. Minus 1 reject.
Minimum time.
So yeah.
Negative time.
So our y minimum is
negative t.
30, right? Our y minimum is 30. What is this? 30 minutes. 30 minutes. Then we suddenly have our x minimum to be 1 in this case 1 kilometer lah, right? 1 kilometer. Okay, our y is the t lah, by the way. Now, how does this help us in any way? He asked you for finding t in terms of x. I mean, I thought we did that in part 1. Actually, what he meant is find the c using this law. That's what they mean. Okay, that's the final puzzle from the integration. You got to solve for the c. This I can use to solve for c. That's what they mean. They put it in a very roundabout way. Do you understand this?
Yes.
Okay, go and find c. And then I think part 3 should be easy. This is not a super complicated thing, except for the integration. It feels complicated at the start. Give it a try.
Find the longest time.
You got to find c first. You got to find c first. Longest time means maximum time, right? It does mean that. Right, what's going on?
I sub in y equals 30, x equals 1.
Into the integration result to find c. Hopefully we got something. Right, so the longest time I think will be just slightly more complicated. Yeah, you got to find c first. You got to find c first.
So what?
Yeah, I think you have to look at the previous page, right? You have to look at the previous page.
5 square root 5 times x over square root 4 half minus 5x. So c is equal to t.
That is equals to the t, yeah, or the y in this case. T or y, whichever doesn't mess up with our brain, right? That is not the result of the integration, brother. I don't think that's the result of the integration. The result of the integration is, sorry, am I right or wrong? Sorry, let me think for a while. No, the result of the integration is this one, right? So this one is simpler. This one.
So if you circle it.
Result of integration. Just gonna.
Okay.
Oh yeah, that means what you did already.
Oh, that I wrote
wrong. Yeah, you wrote wrongly. You're just writing the original thing lah. You're just saying the original thing. So I'm gonna copy and paste here. Keep it there. So it's simpler, right? So do change it. Yeah, do change that.
So we just will square out x.
Yeah, the 2 is gone. Good. Yeah.
So sub in all the x and y's.
Blah 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 blah. You find the c.
X is 1 plus 4, 5. Oh wow! So
yeah, that helps a lot, right? And then this will be, yeah, don't cancel them. Yeah, that's wrong. Right. Hello, yes. Hello, yes. Hello, yes.
Wait,
yeah, it's 25. It's 25. It's 25.
No, square root 5 times 5 is square root 5 times square root 5 is 5. Right?
Correct, right? Yeah, it's not a cancellation, right?
Yeah,
okay. So right. So and then the x is 1. Okay, nice. Yeah, okay, good. Yeah, we got something. The c will be 10. Okay, you got something. Now, previous question and this question, we go and find c in a slightly different way, but we find c nonetheless. This is the instinct you need to have. In application question like this, the c cannot be unfound, so to speak, cannot be left unfound. Right? So whatever you do and whatever the question maker asks you, both of you have to work together to find the c1. Almost confirmed. I hope you have that instinct, right? Now we found the c, which they never even say to you directly, right? But there we go, we found the c. Now part 3 part 3. I am guessing that if we didn't find the c, we cannot do part 3. That's my guess. The longest time taken by Alvin to complete the journey is, wait, let me think for a while. Okay. Now, usually for the longest time, this is let's say this is y, right? This is y. So this will be y maximum lah, which usually means we need the x maximum lah, which means you usually go for dy dx equals to 0. So far so good. That's just the normal way of doing things. Can? Now, this thing, we already did dy dx. We already did dy dx, and we already found only one answer. We're rejecting the -1. Right? -1 in this case will mean something like this, by the way. -1 will probably mean here, -1. That's your -1x, right? Is this valid or not? I don't think so. Yeah, I don't think you should go in that. I'm not sure when I'm reading this question whether you're supposed to go there, but it looks like a very stupid thing to do, right? If you're Alvin, why would I want to swim here and then run here if my goal is B, right? -1 seems like a very stupid thing to do. So far, so good. I'm taking the context into consideration. So, I'm a bit lost here. How come I only get 1x from the dy dx equals to 0, x minimum? It turns out that it is a minimum. And why can't I do something else? Where in this situation, I think I will first sketch the graph. I will simply sketch the graph. Again, using your GC. You don't have GC, right? just going to sketch the graph to find out what's going on. Hopefully, I have an idea based on the sketch. So going back to Desmos, and would you please help me see whether I am correct or not, right? So y equals to 5. Where's my root? Root 5, and then bracket thing x square plus 4, and then this will be a bracket, and this will be a power half. So far, am I doing it correctly? Right. Then minus 5x plus 30. Right. So did I type it correctly? Did I type it correctly? Uh-oh, what's going on? Oh, that's a very weird graph.
Oh, I think we did not do it correctly.
Is there a mistake in my typing?
Where's that plus 30?
That's the C one. Oh, I'm sorry. That's not plus 30. That's plus 10.
C,
Right? That's
yeah,
10.
plus
That's
10.
10. Right, 10. Anything else mistaken? The graph is weird. But yeah, we can do something about that. Let's start from -1. Let's go to 1. There you go. See. There you go. That's the minimum. Yeah, I'm gonna focus on 3 points. There you go. Okay, right. So if I draw this graph correctly, then it's very obvious where my longest point is, correct? Is it obvious to you or not the moment we draw this? Again, I have to focus on this point, and rotate. So this will be my point 2. That's my maximum, right? We only consider this from 0 to 2 because I think it's stupid for Alvin to go minus, right? So this is from 0 to 2. Again, to you, where exactly is the maximum time? Daniel.
At 0?
Yes, I think so. That's it. You cannot use dy dx because that part of the gradient is not 0. But from the graph, it's obvious that's air. That's where x equals to 0. Obviously, it's higher than the x equals to 2, or for that matter, every other part of the graph. That's the highest part of the graph. Done. This does explain why we need the C, by the way, just to be sure. That's it. You solve it by sketching. This is the third time we solve a problem by sketching stuff. So that's already part of my instinct. I hope you have that instinct also. Okay. Looks good today. I will see you tomorrow, right?
Oh, tomorrow? Oh, yeah.
Tomorrow, right? Tomorrow. Okay, yes, in a different timing, right? Something like that. At night or something like that, right? Anyway, I will see you at tomorrow, correct? Give me your questions. All right, good job. I'll see you.
Thank you. Have a nice day. Bye-bye.
You too.
Mau makan? Kayaknya ada sekarang. Break bener? Lagi break sebentar. Iya, Bang.
Yes, hello Andrew, can you hear me?
Hello, yeah, I can hear you.
Yes, all right. Okay.
Sorry, I'm at school right now.
Because you're preparing for CCA, is it?
CCA stuff.
Yeah, right, right. So if I'm not mistaken, you will be quite involved in your CCA this last week, correct?
Yes, this week.
Today, and your mom told me Thursday, the shift should probably be fine. But is there anything else you want me to know, regarding your CCA, in case there are clashes or anything else?
Usually no, but now it's competition soon, so there's a lot more.
Right. So for this 1:30 to 3, right? You're going at school. I think it's fine. Your voice seems good enough, right? What else? Have you eaten?
Lunch, yes.
Okay. Then hopefully you're still quite alert, right?
It's okay if I leave 5 minutes early. I need to report for a meeting right after this.
You need to report when? Sorry.
I leave like 5 minutes before.
5 minutes. So like 5 minutes to 3 lah, right? Okay, no problem. No problem. Now, do you have your laptop?
Yes, I'm using my laptop.
Okay, so your laptop is using the 4G from your phone, just to check.
No, school Wi-Fi.
Oh, Wi-Fi, right? School Wi-Fi. So the school Wi-Fi seems very good. If it is not good enough, I'll tell you. Okay, so looking at the Jamboard, please. So the Jamboard from your chemistry, just continue for there a little bit first. So look at page 4 for a while, right? Tell me when you're in. Okay. Again, tell me if you're in.
Chemistry, right?
Chemistry, yes, chemistry. Then, okay. So again, are you in page 5 of the Jamboard? 4 of the Jamboard. Okay, are you in page 4?
Yes.
So at 2 o'clock, both Andrew and Joshua will come in. And those times when we are together, I will alternate between chemistry and physics. The situation is very simple. Currently, Joshua is more ahead in physics. When I say ahead, I mean what we're trying to accomplish this holiday. What we're trying to accomplish is to prepare for term 3. So basically, Joshua is prepared in term 3, but Joshua is still catching up on chemistry. In fact, he's not here yet. You are here in chemistry. You are almost catching up to Aiden, but Aiden is basically prepared for term 3 chemistry because he already done the exam level question. That means he has already have practices regarding this, something like that. So you notice that we will switch from chemistry and physics when we are together, so that everybody will go up to speed in both subjects. Now, right now, in this half an hour, we are not with anybody. You're by yourself, so we can choose whatever we want. Today, I choose chemistry simply because it's almost done already. At least I have the basic skill explained to you, and then you can start filling up the exam level questions. Okay, that's why we do chemistry right now. Okay, if there is any objection or is there anything that you want to do, you please tell me right now.
Okay, I take it chemistry is okay then, Andrew? Okay, yeah, right. Again, whenever your audio or my audio is not nice, don't bear with it. Just hell. That's bad, right?
Okay.
So now in the Jamboard, I'm doing some laser pointer. Can you see it immediately? Laser pointer. Can you see anything?
Yes, I see it.
If it is a bit slow, again, don't bear.
It's
If
fast. It's fine.
Okay. So you will know when I explain, is it lagging or not? If it is lagging, again, don't bear with it. Just tell me. Yeah? Okay. Now, this is one reaction that you balance. The balance is 2966. This is another reaction that you balance 2316. If you remember last time, balancing can be quite difficult if you don't start with the easy one first. But after a while, things should be quite easy lah. These two reactions are two of the These two reaction is two of the hardest one that you did, and it will be, you don't always see something this hard in exam. So balancing wise, you're okay. I'm going to the next level of mole chapter. The mole chapter is we have to convert the natural units into the mole. The natural unit of a solid is gram or kilogram. We got to convert that to mole. The natural unit of aqueous is volume and, well, how concentrated. Convert that into mole. The natural unit of gas is simply volume. Convert that into mole. Then we can use this, right? That will be the most basic skill in mole. That's our revision. Any questions so far? Okay, we go to page 5 then. Go to page 5, yeah? Now, page 5 is when we change 2 grams of sodium using the MR into the mole, and we are done. No? It's quite easy to change gram into mole. Is it a memorization? Maybe most people approach it that way. Memorize lah, from mass divided by MR into mole. That's it, lo. Something like that. So far, so good. From mole into mass, what do you do? Let's say I have 3.5 mole of Na, and I want to convert it to gram. What do I do?
Times amount.
And that's it lah. Mathematically, it's very simple, right? Mathematically, and that's it for solid. That's it for solid. Now, one thing to comment regarding MR, I keep saying that it is for solid. Actually, it is universal. MR changing gram to mole, vice versa, is universal for solid, liquid, and gas. If they somehow give you 2 grams of hydrogen, just use MR. It's very simple. They don't usually do that though, but I see some questions do that sometimes. You understand me? Right? So the MR is a universal thing. The periodic table is your friend. Done. Now, go back to page 4. Page 4, we are now changing gas into mole. It's very easy. Right? Okay. I'm gonna write this down here. So for gram, mass divided by MR. Mass divided by MR is going to be mole. For gas, is much easier, right? It's much easier. 1 mole of gas, right? 1 mole of gas is equal to 24 dm cubed. Why is this so? Let's just say that you don't know and they don't tell you why. But it is very easy. For example, look at this one for a while. Do you see any MR? Do you see any name of gas in this formula?
I can't see what's written in red. Is it 1 mole
of gas?
Of gas.
Yeah, the writing, my writing is not so good, right? Okay. 1 mole of gas is 24 dm cubed of gas lah. This formula, it doesn't matter what gas, it doesn't matter what MR. whatever the gas is, it will always be 1 mole of gas, 24 dm cube. Okay, now look at the below reaction for now. For example, here I have hydrogen gas, right? The hydrogen gas he say is, let's say, oh, I have 2 dm cube of hydrogen gas. Well, that is 2 over 24 mole of hydrogen. That's it. Do you see the math? Math-wise, math-wise. Because 1 mole gas is 24 dm cube. Therefore, math-wise, 1 dm cube of gas, 1 dm cube of gas is equal to 1 over 24 mole. Does this make any sense? Okay. So therefore, 2 dm cube is simply 2 over 24 mole. I mean, voila, that's it. That's really it.
So for gas, it's always 24.
1 mole, 24 dm cube, not cm cube, 24 dm cube. Why not whole, but super just like that one low? We don't even have to care about what the gas is. Only for gas.
So 24.
Yeah, it's so simple. Now, let me give you another example. So let's say you are given 2 grams of sodium. Then they ask you, produce how many hydrogen in dm cube. Make sense? That will be the question. It's a very simple, yeah, you can say this is still exam level question. Can you? Now what do? I must first go into mole, right? Okay, this will be 2 over 23 mole. Would that be okay? Of Na lah.
Sorry, I still get it. We got a 23 from.
Very simple. Remember, how do we change mass into mole? MR ma? MR of Na is 23. There you go. That's all I do. Will this be okay? I must admit that the equation don't make a lot of sense, at least especially at first lah. That's why I keep repeating for you. Will this be okay? 2 grams of sodium, the MR, so 2 over 23 mole, done.
So do I just round up 22.9 to 22?
Right. So the 22.9, if I'm not mistaken, you kind of Google, I suppose, correct?
Yes.
Okay. So the good news is this: 22.9 is very accurate. You're supposed to use that in JC. If you go to JC and if you take chemistry, you're supposed to use that. In O-level, they give you a periodic table, you know, in the exam paper or in your lecture note. They do. And those things are already rounded off already. For example, they won't show you 22.9, which is accurate. They'll show you 23. Makes our life easier a little bit. Would that be okay? Okay. Googling is fine. You can Google whatever you want. Just know that for now, we'll be using the round up number because that's what they give us in the periodic table. Okay, it's a simplified version. Okay, now any other question like that you must ask. You okay first? Okay, Andrew. Okay, now I go to how many mole of hydrogen? That will be 1 over 23 mole of hydrogen. Would that be correct?
Yes.
Because of 2 and 1, right? That's the only reason why we go to mole. So much trouble for using 2221 lah, for using 2966, for using 2316, whatever you're supposed to use. So from mole to dm cube, well, actually, that's so simple. The answer will be 24 over 23 dm cube of hydrogen gas. That's it. We have finally finished the question. Do you understand what's going on?
Let me.
Yes, please. because the formula does not make a lot of sense for that first one, even though I keep saying it's easy.
Still don't get it. So why does 2/3 molecules of a sodium become 1/23 moles of hydrogen?
This one, right? Okay, very simple. Because back to the equation, which is balance. Back to that. That's the most basic thing. You balance this, and then you say this was 2, 2, 2, 1. That must be correct. 2 molecules of sodium will give you 1 molecule of hydrogen gas.
But doesn't the hydrogen gas come from the hydrochloric acid?
Again, check it out for a while. Correct. H2, 2H. Yeah, I mean, correct. You're correct. You're correct to say that this only comes from here. However, in order to do that, he must react with him. You must therefore take everything into consideration. You must calculate everything together, not just this to that. And the result of you considering everybody together is 2, 2, 2, 1. That is a very good question. Do you understand my answer?
Not really.
Try again. Let's worry about the hydrochloric acid and the hydrogen gases. The hydrogen is 2 and 2 on the both left and right, meaning our 2 here and a 1 here should at least be correct first. So far, so good? Yeah. Now, this 2 will not just affect HCl, H. The 2 will also have to affect Cl, correct? That's the consequence of this 2. Am I correct? As a result, the Cl is 2 on the left and the Cl is 2 on the right. There you go. So right now, this one affects this 2 and this 2 affects this 2. So far, so good?
Yes.
Isn't that like a chain reaction? I cannot let go of you, you cannot let go of him, and voila, he cannot let go of him. Okay, you see my point? They are in the end linked together. That's what a reaction means. There you go, 2, 2. Finally, we have 1, 2, 2, 2. So he is connected to him. No matter how long the connection is, he is connected through this one reaction. It is a very good question. I do wish that you understand. If not, I'll explain more. Does that make some sense?
I guess.
So me, I will assume that there's a connection because I balance it already. The balancing is the resolving of the connection. If I balance, I'm happy. You are happy. If they give us the balance reaction, very, very happy, right? If they don't give us the balance reaction, we go and balance and we become happy. Once we do that, we can, surprise, jump from sodium to hydrogen, even though there seems to be no connection at all. Not true. There is a connection.
Can I ask why the moles for hydrogen is over 20? Shouldn't it be?
Because back to the balance equation, which represents the connection, right? 2 molecules of sodium plus 2 molecule becomes 2 molecule and 1 molecule of hydrogen. So far, so good? So remember the word mole. Mole is not molecule. It's not. Mole is many, many molecules. Avogadro worked out the many, many molecules in order to make it simpler for us. We don't have to even worry. We don't have to even remember sometimes that it is 6 times 0.2 times 23 molecules. Yeah. Avogadro works that out for our benefit. We just say that with the word MOL, not molecule. So this is 2/23, many, many molecule. If that's confusing, just imagine this as 2 over 23, I don't know, 1,000 molecules of Na, just for, help us. If this is 2 over 23,000 of sodium, isn't this therefore 1 over 23,000 hydrogen molecules? Because 2 NO. If this doesn't make sense, please tell me. Please really tell me.
I think it makes some sense, but I still don't really get why. But if why not is 2 HCl and H2? Why is it sodium?
Okay, then let me show you the longer route. There's nothing wrong with what you're asking. Really, there's nothing wrong. Okay, I'm gonna erase this one. There's really nothing wrong with what you're asking. So now, now I'll go one step forward. By right, sodium will affect sodium chloride first. Correct or not? That one you see the connection lah. Yes. Correct or not? So 2 over 23 mole of sodium chloride lah. Correct? Now this should make sense to you. Correct? Okay, now this by right affect your HCl, which is what you're saying, right? Okay, affect the HCl. Okay, then I go to the HCl. So, well, how many molecules would they? Oh, okay, wait, same thing, right? 2 over 23 molecule of HCl. Does this make sense?
Okay, yeah.
Now the last connection is what you wish for, from HCl to H2. There you go. Over 23 becomes 1 over 22. Now, does this make sense?
Could you explain?
Which one?
What you just said.
You mean going from here to here? To here? Is that what you mean? This to this?
Yes.
Okay, okay. Again, imagine this forward. Here is this one. Imagine that there are, remember back then while I was asking you to develop your concept, this is like 2,000 sodium molecule, correct? Hey, you didn't make any, you didn't go and jump from sodium to sodium chloride. When I ask you, okay, what's 2,000 sodium molecule, then you will answer me 1,000 hydrogen molecule, correct or not? That seems to make sense to you back then. Remember, 2,000 of this, we'll need 2,000 of this, and we'll produce 2,000 of this, and 1,000 of that. Isn't that correct?
Yeah.
Right, so if I go 2 million, is there really a difference, like 2 trillion? Is there really a difference? 2 trillion needs 2 trillion, give you 2 trillion, and produce 1 trillion here. Confirm one. And then I even give you ugly numbers. Do you remember that? I give you ugly numbers. So ugly numbers look like this lah. For example, 3.57 whatever lah, 2.57 thousand sodium, right? Is there a difference? This will be 3.57 thousand, 3.57 thousand, and this is 3.57 divided by 2,000. That's how the math works. That's what you said back then. You can deal with ugly numbers. You remember that, correct?
Yeah.
So I have given you an ugly number, 2 over 23 many molecule. If you're really very disturbed with the word mole, don't be. Change it in your mind into million for a while. 2 over 23 million sodium. Is there a difference? This is 2 over 23 million, 2 over 23 million, 1 over 23 million. Is there really a difference? Slow down. I'm not trying to make you faster. Slow down and see whether that makes sense, because this keeps happening in every question from now on. Better understand this. Don't understand, better ask again.
So yeah, I get it.
Yes, go ahead. Explain to yourself. Yes.
part I don't get is I know it is 23 moles of sodium,
Yep.
but I don't get how that is equals to 1 mole of 1/23 moles of hydrogen.
Okay, again, let me try to make it make sense. Let me try to make it make sense. Right? I'm gonna give you an ugly number in another way. Okay, I'm gonna try it. I'm gonna give you this 1,500 sodium molecule instead. Okay, so far so good. Notice that 1,500 is not exactly 2 lah. It's not 2,000. It's not 2 million. It's not, you know, the kind of thing. But again, now let me ask you, how many HCl molecule is needed?
So the same as
How many? Okay, Joshua, I can see you. Yeah, can you hear me, Joshua?
Yep, I can hear you.
All right. While waiting for the rest, there'll be Aiden one more. Have you finished your pressure homework or any other homework, I suppose?
I haven't finished my physics homework, but I think you can, if we're doing something else today, I think you can just save it for Wednesday.
We can. That means today we'll take turn between physics and chemistry. During physics, you're way ahead. So you do your homework, lo. Makes sense, right?
Oh, okay, I
In
see.
chemistry, which is the next 45 minutes, either one, start or end or whatever, then you pay attention, if that makes sense.
Yeah, okay.
You alternate in between these 3 days. Hopefully your chemistry is up to where I want you to be. If not, we'll see what happens. But your physics is almost done. Let's do that one. Okay. So while waiting, Eden, would you please do your camera and physics first? Yeah.
Yep.
Okay, back to you, Andrew. 1,500. HCl will be
1,500.
all right. NaCl. H2.
1,500.
Divide by 2, correct? Which is 750, whatever that number is 1,500 divided by 2. That's the point. I divided by 2 because ratio 2 to 1. That makes sense to you, right? So does this make sense to you now? 2/23 divided by 2 is 1/23 now. That's it. Right? Math-wise, that's it. But the chemistry behind is I don't know how to say it's rich lah. It's rich. It's not as simple as divided by 2. The reason is given in the chemistry.
I get it now. I think I misunderstood because I thought it's like 2/23 moles of sodium turned into 1/23 moles.
Oh, hydrogen. No.
So, I get it.
It is this together with this, which produce this together with that. But of course, the question will shortcut it. The shortcut is implying that everything else is needed. Of course, everything else is needed. Just I don't care about everything else. I just want to get to what I want, something like that. Are you sure your doubts are clear so far?
So far.
Okay, so far, good. We go slowly. This is a very important part. So 1/23 mole, and we have the last job of converting to dm cube, that's what we do here. Dano, are you okay with that?
To convert to dm cube,
which is the normal thing that they ask for gas lah. They did, and we need this relationship lah. This is the new thing I tell you today. This is the relationship, and I was just using that actually. It's a relationship that does not make a lot of sense. Okay, admit, but I guess we use it a lot, so we kind of just memorize them. Can you accept that? And therefore, our job is done. This is like the first 2 marks in an exam question. You just go from 2 grams back then, 2 grams of sodium into how many dm cube of a gas. Pretty normal. Okay. Are you sure? No more questions? Okay, so again, while waiting for Aiden not here yet. Okay. Before, let me ask you. Okay, I'm gonna copy this. Okay, so I'm going to page 5. You can do it with mouse, you can do it on paper, quite simple. So I'm going to reverse the process. He is giving you the M cube. Give the M cube. Given. This is, let's say, I don't know, 0.5 the M cube.
Sorry, do you paste the picture there?
Yeah, that's a picture.
It isn't loading on my screen.
Okay.
It's just like a white blank.
You'll be, if it doesn't load in another half a minute, you tell me. Yeah, you tell me. It's just the same reaction. Right? Given. And then how many grams of sodium will this be? Okay. So again, should be the mole first, and then should be the mole first, then should be the gram. Right. Can you see the reaction already? If you cannot, for now, look at the screen sharing and then do this question. Do this question. Okay, looks like I have to WhatsApp Aiden. Joshua, if you have a video, that would be nice later.
Sorry.
If you have a video, that would be nice.
Okay. No, because my homework is online, so
Yeah.
yeah.
Which means you're doing it on paper, but your working might be on paper, but you need to put it on the online.
No, it's fully online.
Right. But you
Yeah.
do some working, right? No?
The working is all online. They gave like a online paper, and then you can just use your PLD to annotate on it.
You
Yeah.
have PLT. You have some sort of writing tab.
Yeah.
Oh, that's so nice. Oh yeah, that would be useful for us also.
Mm,
So I guess I'll follow you using the previous Jamboard first.
okay. Sure.
Or Aiden also. Okay, so Andrew, I cannot follow you. Yeah, are you okay so far? Okay.
Sorry, could you really explain it for a second? Trying to see.
Andrew, are you okay? Okay, so for you, Joshua, Aiden is not joining today. Yeah, he has a wisdom tooth operation. I guess it's good now. This is good now. So that means, Joshua, we can jump to chemistry for a while. Okay, let's catch up with chemistry lah, right? Okay. Would you please look at your screen sharing? Remind me again where you are in chemistry. Okay.
Okay, yeah, sure.
Can you hear me?
Yeah, I can.
Okay, I can hear you.
I'm on acids and bases, right? I just like barely touch acids and bases.
You think
Yeah.
of acid and base, and then you definitely haven't touched mole, right? So
I have touched mole.
Oh, wait. Of course, your
It's
mole.
reverse.
I keep, yeah. So when I'm briefing acid and base, then you should be in. Okay, let me confirm one more time that you're very familiar with this, right? For mole, this is the reaction. It is balanced. Okay. If they give you this amount of dm cube for the hydrogen, do you have any problem finding how many gram of sodium is needed?
Convert to mole, so 24
times 5 by half, right?
Times half. Yeah, divide by. Wait, is it divide by? No, times half.
Right.
And
actually,
then you get
it's
the mole.
divided by 24. It's actually divided by 24 lah, in that sense. Right. You get the mole.
Yeah.
And
then you
the
multiply by the atomic mass.
But before that, you need to get the mole of the sodium first. Not that fast.
Oh yeah, and then multiply by 2 because it's
right. So it's
1 to 2. Yeah.
Correct. 24. And then you multiply with the MR. The MR is 23 lah. So what do you get?
1/24. 0.958.
Correct.
Yeah.
But I'll keep it as that nicer number, 24/23. 23 of that. Okay, good. Then kindly do your physics again. Right.
Yeah.
Okay, so Andrew, by discussing it with Joshua, we end up doing this lah. Do you have any concerns? Is this
I just recap on the how the working. How could I see the working?
Right. So what happens in the first step? This is a first step. So I remember the relationship. No? The relationship is 1 mole of any gas is equals to 24 dm cube, right? If I don't like this relationship, remember that I can always change it to 1/24, right? I can do that, 1/24 mole.
Yes, 1.
And then 1 dm cube. So depending on your situation, you will prefer one or the other lah. So you just use whichever you like, right? So which one do you like?
The second one.
The second one. And therefore, the second one will give you this answer. Does that make sense?
0.5. Yes.
Over 24, which I don't think you should go for decimal. I think going to decimal here is not very helpful unless you really hate this kind of fraction. Do you hate 0.5/24? They also don't, because they know this is, an intermediate working. They know that. If this is a final answer, we go press calculator, convert it to, whatever ugly decimal points there is. Right? But this is not. From 0.5/24 into this. Any question?
All right. 2
First times 2, right? Times 2, 1 to 2, right? And then remember the relationship, right? So the relationship is mole over, mass. Mass over MR is mole, right? That's the relationship. Of course, mathematically, you can just write down as mass equals to mole times MR. Whichever helps you, you use lah. So which one will you use?
First one.
I think the second one, because you have the mole, you have the MR. So you use the second one.
Okay.
Make sense? So times 23 lo, and I have 23 over 24. Then I press the calculator lah. But at that point, it doesn't matter. You already got the correct answer. Does this make any sense?
Wait, so the MR of sodium is 23, so 23 times 1 over 24.
Is 23 over 24? Yes.
Okay, good.
Based on the relationship, which admittedly must be memorized.
So the answer is in grams. This one is
Yeah, yes, sir. The relationship doesn't tell you, but it is in gram.
okay.
I hope this makes some sense.
Yeah.
Right. We continue doing this until you feel very comfortable with it, and then suddenly, I mean, you can do it lah. You can do it. So another one, still the same reaction. Joshua, just to confirm, any questions so far?
I posted it on page
12.
12,
Right?
yeah.
Okay, good. So Andrew, I'm going to give you a question, and then you're going to do it. Okay. This one, try to do it yourself in the sense that you must post the answer for me. Right? Now, tell me an ugly number, please, Andrew.
0.2.
0.2, you're saying 0.2? Okay. I'm going to do it 0.21. Okay, even uglier. 0.21 dm cube. How many grams? Also, that's question A only. Question B. 0.21 gram. How many dm cube? Understand the question? Okay, please do so. All right, Joshua. Not sure about the question itself, but you're saying that determine the length or not. Okay. So, oh, not stretch. How come you have a stretching? Okay, so I'm not too sure about this question. Can you give me the whole thing?
Yeah, sorry, I'll give you the whole thing right now.
Yeah.
Yep, there you go.
All right, nice. Okay, so it seems like there's some sort of measurement. Okay, nice. Position C. I see. Now I understand. Right. Okay. All right. Okay. Find it to be a bit weird. Okay, right. So there's question 1 and then there's question 2, right? So the length of the bungee cord when it is not stretched is it should be at position C, am I correct?
When it's yeah.
So we gotta know this length. Obviously they don't give us, right? So that should be you trying to figure it out, right? You're figuring out by drawing a graph. Now tell me what graph is this? Just to confirm, what graph is this?
VT graph.
Good. I agree with you. This should be a VT graph, and this is the data that you're using. You can use the first jump, I think, right? First jump shouldn't matter, right? So your first jump seems to start from 0, right? Going to 5, 10, 15, 17, and then going back to 0. I think it will be the one
going to 17. I believe this is where our C is. So there might be
yeah,
a slight, oh,
should be.
oh, you understand. So you know
Yeah.
that C will be from 0 to 17, right?
Yeah.
I don't see this graph drawn in your drawing. That looks
It's a
different.
bit, okay. Yeah.
It's a bit different. So
Alright.
maybe you want to try that.
Okay, sure.
Right. Oh. Oh no. Oh, you're saying Andrew, yes, sorry.
The answer for the first part A, 161 over 4.
I'm correct. 161 over 40. 400. All right. So I'll do it quickly. Sorry, Joshua, I'll make a correction. I think the C is here. Yeah, ignoring air resistance. If you are ignoring resistance, then this will be the C, I believe. This will be wrong. I believe. Let me explain it. Right. So for Andrew, the first one. So let me just go through the process with you. Right. So this should be 0.21 over 24 mole, correct? Then this should be 0.42 over 24 mole. Make sense? And then this should be times 23 lah. So if that is your process, then I'm not sure about the fraction, but it looks about right to me lah. But then again, yeah, it does look about right to me, right? I'll probably draw it in decimal later. So your process is correct. Your answer hopefully is correct. Any questions so far for part A? If there is no question, could you do part B, please? Okay. Joshua, are you okay so far? Can you draw something in the Jamboard?
Okay, hold on. Let me screenshot my updated graph.
Sure thing.
I tried this, the 17, right? But wait, why is it not at 17 though? Isn't it 17 like?
All right. Okay. So he tells you this, right? So I was thinking about this carefully, lah. Right? This is not a joke question, lah. So, but this is the G, lah, right? G, and there is no air resistance, so it makes our life easier. Therefore, when the cord is not stretching, right? The cord is not stretching means the cord is not pulling you up. There is no force, lah. So at this point, the upward force is equal to 0, correct? Starting to stretch also means from here to here. I mean, the F is still 0. So what does that mean? So sigma F equals to MA, right? So when no stretch, that sigma F is simply just W going down. Right? There is no minus F bungee, right? Minus F bungee, and the F bungee is 0, equals to MA. So then he tells us gravitational field strength is 10. So definitely W equals to MA, MG equals to MA. My G is my A lah. That means my A is 10. 10 downwards. Now look at that for look at this thing for a while. So at 1, my velocity is 10 from 0 to 10. That looks a lot like acceleration 10, no? That looks a lot like it. The acceleration is 10. So far, so good.
Okay.
So at second 1, I believe so. At second 2, I still believe so because half second 5, no? Half a second 5.
Okay.
However, looking at 2, I'm expecting 20. If this is
okay.
But I'm not. So I'm having a bit doubt there. I'm not sure what's going on here, but that looks like the sigma F is no longer just W. It looks to me like that.
Wow. Okay.
Right. Is that something difficult to notice? I suppose so.
Yeah, I couldn't notice it the first one as well.
Yeah, you probably wouldn't notice. You probably be easier to notice if they draw the graph for you, and yet they don't. That's fair, because in experiment, what you get are this kind of thing. Then you go and draw the graph. So he's like giving you like a very realistic way of doing it, minus the air resistance. So it's difficult because it's realistic, something like that. But that means we are learning something.
Yeah.
So go ahead. Right. Andrew, how's part B?
Is it 21 decimeters cube?
Okay, let's find out. Let's find out. You say it's 21, right? So how I would do it is this. Remember, I don't know the answer key, right? I don't have an answer key. We just made this question, right?
Okay.
So, is it 21? Let's look at the process. So first of all, it will be 0.21 over 23 mole, correct? Of sodium. Would this be okay? And then it'll be 0.21 over 46 mole for hydrogen. Sodium, hydrogen. Okay. Will this be okay? And then times 24, right? So 0.21 over 46 times 24. Now, it doesn't look like this is 21 dm cube. I don't think so. I think it's smaller than that.
Wait, it is times 24
because back to the relationship, which again does not make a lot of sense, but you should remember this one. So there's a relationship A and then relationship B. In our case, which one is helping you, A or B? A or B? A. Then I will agree with you. Then you know what? Just if this is 0.2146, then this is just 24 times that, right? 0.21 over 46. Again, this needs to make sense. Take your time. The numbers are very ugly. It needs to make sense. Right, Joshua, I hope you have some modification. Yeah, now I'm sure, because I was thinking about the 17. It appears to me weird at first, but now I'm very certain. I have an explanation. The explanation is beyond your syllabus, but I do have an explanation.
Ooh, okay.
So I'm very sure that C should be considered at 1.5. More likely it's between 15 and 17, but we don't know. We don't know what position is that, so I can only take C as 1.5. I cannot speculate. So if you just draw 1.5 and 15 for the VT, you will get the distance quite easily from there, I feel.
Okay.
And if you have the answer key, that's great. If not, then we'll just have to wait. Andrew, what do you think? Does this all make sense?
Yeah, makes sense.
All right, then. You are now getting used to the relationship and the ugly number. Why am I doing this to you? Because the ugly number will be there in exam 1. The ugly number messes with people's understanding. It's like if it's an ugly number, I cannot think. If it is not ugly, if it's nice, then I can think. I mean, I think that's correct. Ugly number messes us up, makes us less confident. And that's why I'm training you with all this, right? So that your understanding remains intact, right? When you have to deal with ugly numbers. Now, I have one more relationship to tell you. Go back to page 4. It will be the A equals 1. The A equals 1. In the A equals 1, according to your experience in lab, your teacher will tell you to take how many milliliter, for example, how many milliliter or how many centimeter cube, right? And then he will also have to tell you about the concentration, right? Isn't this your experience in lab, Andrew?
I don't think I've done that yet. Concentration.
Right. Now, that's fair. You haven't learned acid and base, and you haven't learned this mole. So it's a bit rare for it to happen. So we're going a bit ahead, exactly what we want to do lah, right? So go back to new page 6. Let's discuss this new thing. So in the reaction that we are using, we conveniently have aqueous law, right? And we have conveniently have an acid. So Joshua, I will agree with your graph. Using that graph, you'll be able to find the distance. Do you know how, Joshua?
Yeah, just use the
Area lah.
half area.
Correct. And then you're done. Should be the best answer lah for that. Okay, so for Andrew, so we're going to use HCl lah, right? So use a nice number first, right? So I'm going to ask you for 50 milliliter. At this point, I have to tell you immediately, 1 milliliter is 1 centimeter cube. 1 liter is 1 dm cube. 1000 centimeter cube is 1 dm cube. Do you know all this relationship? Page 5. Hey, page. Wait, what page is it? Oh, surprisingly, I'm sorry. Surprisingly, okay. Please go to page 6. I did the wrong order just now. Right? Would you please now go to the correct page 6, Andrew? It's the one after this one. After why? Okay, sorry. Sorry about that. Okay, so again, HCl, 50 milliliter of certain concentration. I'm telling you the relationship first. This, and that. Are you familiar with all this? You're muted, Andrew. I think probably you're muted. Yeah, you're muted. Right, okay.
What's the second number? So 1 liter.
1 liter. Yes, 1 liter. The liter that you know is 1 dm cube. Now, I don't want you to be, blind about this. Here's 1 centimeter cube. Here's 1 centimeter. It's very easy to imagine. Here's 1 centimeter.
1000 centimeters.
Correct.
How to memorize it?
I'll give you some understanding first, really, because to be fair, you'll be needing this until forever, right? So 1 centimeter is not difficult to imagine. Yeah, that's 1 centimeter, right? I just draw that in your Jamboard, right? That's around 1 centimeter, no? Correct. Am I correct? Don't mute, yeah, don't mute. Okay, so 1 centimeter cube is a cube of 1 centimeter. There you go. I just draw for you a cube made out of 1 centimeter side. This is 1 centimeter cube, right? A cube of 1 centimeter. This is 1 milliliter. Kind of easy to imagine because 1 centimeter is easy to imagine. So far, so good. 1 dm cube is so easy. 1 dm cube is 10 centimeter. See, I draw for you 10 centimeter. See, 10 centimeter cube, 10 centimeter cube around there. That is around 10 centimeter cube, really. Don't you think that's 10 centimeter? Imagine the 10 centimeter cube. That's your 1 dm cube. Why do I know 10? Because 10 centimeter is 10 times 10 times 10. 1000 centimeter cube is 10 centimeter times 10 centimeter times 10 centimeter. There is your 1 dm cube. It's kind of easy, hopefully. This is now your 1 liter. For some reason, they make it very convenient. That is your 1 liter. This is your 1 milliliter.
So 1 liter is 1000 cube.
Which is 10 times 10 times 10, 10 centimeter cube. Imagine it that way. That's your 1 liter. 1 liter is neither too big nor too small. It is within your size, the size of your hand. Maybe I will say that. Make sense? In lab, normally, therefore, they won't ask you to take 1 liter. That's like too much and very dangerous somewhat. 50 milliliter sounds about right. That's what they're going to ask you to take. So you have to deal with milliliter or centimeter cube most of the time. Can you? This is your volume. Joshua, just to confirm, you're okay so far? D, right? Accelerating. Why the man is accelerating upward at position D?
I know how to say it. I mean, because to make it 0 has to decelerate, right?
To make it 0, you have...
from like 17 to 0
yeah,
has to decelerate, and then that means going down means accelerating, going up means decelerating.
Now up. Okay, leave that first. Leave that first. I will explain to you very clearly. Leave that first. There's that. Yeah, leave it first. Do something else.
Okay.
For 1 mark, the explanation is a bit long. And did you start off correctly? Maybe. I don't know. Okay, give something else a try first. Let me give Andrew his. Okay, so the concentration, Andrew, the concentration is usually written as mole over dm cube. That's the unit, usually. Okay. 0.1 is a very strong concentration. Never mind the 0.1. 0.1 is extremely strong acid. Okay, so it's a dangerous one. Andrew in the lab, 50 milliliter of 0.1 mole over dm cube HCl please, right? Our job is very simple. Convert it to mole. In paper, that's what we need to do, right?
Okay.
In paper, it is extremely simple. This looks complicated. None of the conversion are complicated. It just looks like it. Look at it. Look at it. This is, of course, 50 centimeter cube, right? Of course, 50 centimeter cube, which is, of course, 50 over 1000 dm cube. Correct? Right? Simple stuff. Do I bother with the decimal? Actually, I mean, decimal makes me more confused, really. I hate decimals. But teacher will, of course, go and write 0.05. I mean, I don't consider that an improvement for my thinking. So I don't like it. If this is a final answer, I go and do it. If this is not, I totally ignore the 0.05, nor the teacher will bother you if this is the working in between. You hear me that? It's totally okay one. Now, again, I hate decimal. Doesn't mean that you have to hate it. But nobody say that you have to like it also. You choose whatever helps you think. I think this helps me think. So I choose this one. Understand? Now, why am I bothering to convert to dm cube? Because the unit in concentration is usually mole over dm cube. It's not, unfortunately, over milliliter or centimeter cube. That's just how it is. So far, so good? So I'm going to take this one and I'm going to take the concentration. Look at how I combine them, right? So one is dm cube and one is mole over dm cube. And my goal is, of course, mole, correct? That's my goal. It's so simple, right? Based on the unit, I just times them. Simple. Correct? If you can see the unit like that, you are a very happy man. 0.1. So what is this? I guess I can now write down as, actually, I don't care. I don't care. I'm just going to write as 5 over 1000. I like that better. If you don't like it, you just write down as decimal. Yeah, as long as it doesn't confuse you, doesn't matter. Choose whatever you want. My point is, I don't even teach you any formula. My point is, just look at the unit. It's so simple. Okay? It's so simple. Never mind the formula. The formula confuses you. Just look at the unit. For solid and gas, you do need the formula. This one, just logic only. Okay. Okay. Now, once you get the mole, then you can get whatever you want. You can get the hydrogen gas one. You can get the sodium one. You get what I mean. Okay?
Yep.
Okay. So now I'm going to give you the question. Right. So what they give you is given. So they give you, okay, go and take 20 milliliter, right, of not so strong acid. So of not so strong means 0.01, right? 0.01 mole over dm cube. So then they ask you for how many dm cube of hydrogen gas produced because of that, and how many gram of sodium is needed. They ask you for both. Can you handle it?
Sorry, what's the second part?
they give you this, right, for the acid, and then they ask you for both the hydrogen gas and the sodium one also. Can you do that? Give it a try. All right, Joshua. So just checking your new question first. Are you okay with your new question? Haven't seen anything. If you're okay, we can talk about the previous one first.
Yeah, I can talk. Yeah.
Okay, talk about the previous one. Right. So it goes something like this, okay? Regarding accelerating and decelerating, let's settle that first. I think what they want is something like what I'm saying to you, right? So let's go this way. So from positive to more. Okay, I'm going to stop my screen sharing. From positive to more positive. This is called accelerating. From negative to more negative is also called accelerating. It's weird. You are becoming more negative. That means you are adding to your negative direction acceleration. You call that accelerating. Some people find this okay. Some people find this confusing. Oh, the opposite is deceleration. From more positive to less positive, from more negative to less negative. That's it. That's, I think, how they use it.
Okay.
This might or might not be how you think about it. Now you tell me first whether this makes sense or not. To you, lah.
It makes sense. It makes sense.
All right. So let's look at this one. So at this point, he has basically defined bottom as positive and upward as negative. So far, so good. And once you define it this way, it works for acceleration, velocity, and distance. The same way for the negative one. You cannot change one. You cannot say for acceleration, yeah, bottom is positive, but for velocity, bottom is negative. You cannot say that. They cannot say that. It's very confusing if you do it. So far, so good. Yeah. So that one, I think everybody should agree, right? So now, this negative velocity will mean a velocity upward, right? Something like that, right? Now let's talk about the forces and acceleration, right? So actually, I will answer the question the way I want it first, then we'll talk about the acceleration, deceleration. So here, the acceleration is not necessarily zero. Position at the lowest point is definitely velocity zero, correct?
Okay.
However, I don't think acceleration is zero. Remember, velocity zero never actually meant acceleration is zero. So in terms of forces, remember there is W, correct? And then there is F from the bungee cord, F from bungee cord. At this point, I believe the F from the bungee cord is already bigger than the W. Now, why do I say this? This is outside your syllabus. However, it is inside your immediate experience. You do know what a rubber band is, right? A rubber band works just like for bungee cord. When you pull it a little bit, when you stretch it a little bit, you feel that it is not very tough. You stretch it more, at some point, it will feel very tough. Bungee cord and elastic band that you have is the same thing. The more you stretch, the more F he gives you. The less you stretch, the less F he is giving you. Will this be okay so far?
Okay.
So at position C, my FB is 0 because I'm starting to stretch. At position D, I stretch very much already. My FB is currently, first of all, quite big. It is big enough to stop me. Correct? It is big enough to stop me. Secondly, it is not just stopping me. he is going to, after position D, pull me up. How can he do that? How can he do that without a negative acceleration? I am very sure at point D, my acceleration is not 0, but negative. Negative means upward, because I'm going to go up after that one. That's how bungee jumping works. What? I don't just hang there one.
Okay.
So my acceleration is negative. Therefore, W will be, I'm sorry, I draw it wrongly. Smaller than FB. Sorry, smaller than FB. Therefore, W minus FB will be a negative, which will give me a negative acceleration here. So in terms of forces, at that point, the bungee cord tension, the bungee cord tension is at its biggest, and it is bigger than the weight, causing a negative acceleration. Negative acceleration means upward acceleration. How do I know? Because after that, he starts to move up. That's the shortest explanation I can give you. You're gonna ask me if you're confused or not. Andrew, are you okay so far? Sorry, I cannot hear you. No, still I cannot hear. Maybe you speak slightly louder. Yeah, maybe.
Can you hear me now?
Nah, much better. Very good.
Okay. I think for the first one, for the number of moles, 20 moles is 1/5,000.
Okay, let's check. Yeah. So this is 2/1000 dm cube, right? Correct. Times 0.01 mole over dm cube. How do we know how to times? Because here the unit will give us mole. So that should give you 2/, in this case, 10,000 for now, which is definitely 1/5,000. I agree with you. That's the mole. Okay. This kind of mole, just tell you in normal question is a very normal answer one. That's small. Yeah, I mean the MOL is a lot of molecules, so it's normal. 1/5,000 molecule, very good and good. And what do you do with it?
For hydrogen, I took the answer and divided it by 2.
Which you end up with 1/10,000 again, right?
And then multiply it by 24.
And that will be your answer.
24/1000.
Yeah. And they may want to put it in cm cube. Maybe they want to, which is 24/10 cm cube. Just like that. Maybe they want. Okay? Simple stuff. Okay, can you simplify this? Of course, we don't care, right? For sodium gram?
23/5,000.
Mole, gram, which is a very small number, but that's it. Done. You okay, Andrew?
Yes.
Okay. Very good. It's done. Let me give you an exam level question and see for yourself whether you can at least understand the question. That's right. Okay. Joshua, what do you think so far? Is there something that bothers you? I guess I like it that you practice kinematics again, and the thing just gets harder, isn't it? The thing just
yeah.
I like it. I like it. I mean, I hope you don't mind. Like it. That's what you do.
It's how do we if they ask like how do you know the tension from the bungee rope is greater than the weight, something like that?
Okay, because you don't know how a bungee cord works, right? That's your greatest disadvantage. I know, right? I know that first of all, if you pull it longer, it will give you harder, and then I can do something else to ascertain that is greater than weight, right? So when the weight is equal to the FB, so let's talk about that situation. When the weight is equal to FB, my acceleration is 0. Weight equals to FB. Therefore, my acceleration is 0, correct?
Okay.
Therefore, since I have been going downward, the velocity should remain positive if my acceleration is 0. Because I start off, remember, I started off with a positive velocity going down. If my acceleration is 0 at some other point and I'm still velocity positive, I will continue to be velocity positive because there is no acceleration, there is no change in velocity.
Hmm.
In order for velocity positive to hit 0, very likely I need a negative acceleration.
Okay, makes sense.
That's how you do it, man. So because velocity actually reaches 0, I know it is acceleration negative.
Yeah.
Let me put it another way. If acceleration is only 0, you will just hit terminal velocity what? That's what you learn every time. What? Terminal velocity. Terminal velocity means the velocity is not 0. Correct?
Yeah, yeah.
So bungee cord should be bigger than air resistance, because if not, you will hit the ground with terminal velocity. That is not very good. The bungee
Okay.
cord should be giving you more than acceleration 0. That means negative acceleration to save you from hitting the ground with terminal velocity. The sooner the better.
Okay.
That's for you lah. How you want to phrase it, that's up to you. It's not worth 1 mark, by the way.
Or at
It's
least
1,
2.
at least 2 or 3. But why is he giving you 1 mark? Because mercy. This is the hardest thing to explain. Just want to differentiate between the good student and the excellent student. To do that, let's not demoralize everybody. Just give this 1 mark, even though it's totally not worth it. For those who want it to be good, they will ignore this mark, no? Right? For those who really, really insist they want to answer it no matter what, they'll give it a try no matter what. It depends on who you are. I'm not forcing you to understand this part. First of all, it's a bungee cord thing, which is outside the syllabus. Secondly, it's beyond terminal velocity, which is again outside the syllabus. If you belong to a student who want to be excellent, then this is a good time to answer this question because you at least have all the basics right. You just want to go one step further. Doesn't matter the cost. But not everybody should do that, especially in exam. Clear, yeah?
Yeah.
This is not 1 mark, clearly not. Okay, Andrew, okay, now I can give you, oh goodness me, you have 3 more minutes, right? You have 3 more minutes. Okay, let me give you. Oh, too hot, too hot. So yeah, okay. Very good. Okay, I got it. Okay, here is a sample of an exam question, Andrew. Look at it in page 8. Do whatever you can do, and then when you have to go, you tell me and you just go lah for today. Okay?
Okay, thank you.
You will hopefully find them to be not so difficult. Joshua, are you okay so far?
Part E and then part 1 and 2 of E.
Did you put anything?
No, it's I think I can do this on my
Oh,
own.
sure.
I can I can put down more though.
Yeah.
Uh,
Okay, Andrew, are you trying something?
Excuse me, I think I have to.
Yep. We'll continue here tomorrow lah.
Okay, thank you.
Okay, I'll see you, Andrew. Bye bye.
I think we can move to chemistry if you want to.
If you wish. So acid and base. Wait, let me think for a while.
Yep, sure.
Oh no, I prefer to cover acid and base together with Andrew lah. So easier lah for both of you.
Mhm.
You are lacking acid base and salt preparation. That is quite a discussion. And after that, you should be very stable. Oh no, not kind of stable for term 3. Because we have not done any chemistry, isn't it?
We have not done any chemistry. It was the only the one that we did with Aiden, I think. Yeah, Aiden.
Which is the start of acid and base, right?
Yeah, the start. The metal oxide, was it? Metal oxide,
I was
metal hydroxide.
listing down all the acid
Yeah.
and bases with you, right?
Uh-huh.
Okay, good. Okay, let me think. So on physics, I don't want to go further. No, actually, I do want to go further than pressure, but I also want to do it with them. Wait, does that even make sense? Does that even make sense for a while? Let me think for a while. But your chemistry is needing it more right now. So yes, I want to confirm that that's happening with Andrew.
I think I just need a bit more help with my physics, but I don't know.
I think so.
I think it's good with chemistry as well.
Correct. Because currently your physics is good, but because you're ahead, right? Your chemistry is not. Anything carefully. Yeah, I want to do that with. Oh. Okay. This is what I'm gonna do. We're gonna do some physics, and I'm gonna introduce the next physics one. It's introduction for half an hour. Okay. Will that be okay? That we call most likely energy work power, right?
Okay.
Energy work power. It's not supposed to be very difficult, but yeah, come. It goes from P5. Back then in P5, you will have
Back then, you learn about gravitational energy and kinetic energy. Secondary 1 and 2, you learn that GP is KH, and you learn that KE is half mv squared. Was it?
Yeah.
What I want to summarize is this. Whenever you are in this topic, it's obvious that something is falling or going up. Going up,
Okay.
falling down. Because by going up, you're increasing the GPE. Must be. By falling down, you are decreasing your GPE, usually by becoming KE. Not all the time, but usually. So to know whether a topic is, now it's called energy work power. To know it is very simple. Just observe whether the thing is moving up or moving down.
Okay.
Rarely it is just moving horizontal, but yes, it does happen. So why horizontal? Because by moving horizontal, usually there's some sort of KE happening. No? Yeah, I mean, you're still moving, to be fair. You are still moving. So moving up, moving down, or moving forward and backward. Okay, then you may say, yeah, but the bungee one also what? To make it very clear, from now on, the bungee example for just now can be used for energy work power also. They can just involve the topic immediately. That's the answer. For your, I thought there's already a mass moving up, down, left, right in the previous kinematics and dynamics. You are correct, and they can just involve energy work power from now on, something like that. Okay.
Okay.
They don't have to, but they can. Okay. Now, their interest, therefore, is not just moving up, moving down, or moving horizontal. That means they're just trying to make your life harder. You can already solve it with, for example, sigma f, or you can already solve it with some other thing. Then you're adding this just to make your life or our life more difficult. Well, the reason is because there's something else that they want you to tackle. So it's the energy, this is the energy part. And then your work. Work basically means you continually push or pull. And this is continual. Usually, they will ask you to imagine you doing the work. You pushing up, you pushing it from left to right. You probably don't want to push it down. No need. They're just wrong. Okay. So you're pushing it or pulling it, right? So then they will develop it to other people doing the work, or rather other things doing the work. Thing doing work. Which feels very weird until later on you realize when you work, you push or you pull, meaning you give an F. You give an F continually. Therefore, anything that gives an F will be considered doing work in physics. It's as simple as that, by the way. It is as simple as that. Okay? Okay, so last one, work, energy, and power. Power is hopefully the easiest of the bunch. This is
It's like a rate of work, right? Work done.
Correct. So the rate of work or the rate of energy. Now, how can I say both? Because surprise, surprise, energy is joule, and the work that you put it in is
also joules.
So rate of work or rate of energy being gone. The point is, it's just work over time or energy over time. That's the easiest part, to be fair. So when you're doing work, you can do work fast or slow, keeping it simple. When you roll down, you can roll down fast or slow. When you that sort of thing. The power is just like that, right? Now, let me start with energy and work first, right? Energy is your bank account. Or your wallet. You have a bank account and a wallet? You have a wallet?
I have a wallet, yeah.
You don't have a bank account?
No.
You have something else that hopefully works as a bank account. You have
piggy bank, does that count?
Piggy bank or EasyLink, either one.
Yeah.
Okay, let's go piggy bank. I like piggy bank because piggy bank is less liquid. You have to take it out, put it in your wallet, and actually preferably change it to bigger numbers lah. I mean, I don't want to bring coins everywhere, right? I don't want. Okay. The way I save it, I save coins. The way I use it, I don't want to use coins. Piggy bank is less liquid. It is kindly, it can be thought as your GPE. Remember, GPE is joule, okay? Your wallet is KE. And I use wallet as KE because in your wallet, your money tend to disappear, not appear.
Okay.
Wallet is meant to be used. That's why you put it in your wallet. You don't tend to, I want to keep a lot of money in my wallet. First of all, it's very thick. I don't feel very safe bringing it around. I might as well.
Yeah.
If I want to keep it, I keep it in my piggy bank, in my GPE, my GPE. If I want to spend it, I spend it in my KE. So let's call our wallet our kinetic energy. Let's call our piggy bank our GPE. You notice, yeah, if I take out from my piggy bank and I put it in my wallet, my total is still the same. That's what you call total. The total is total between your piggy bank and wallet. That would be your total money, correct? Also in joule. So when I say joule, I mean dollar. When I say dollar, I mean joule. Your piggy bank has $700. Good for you. Your wallet has $50. Good for you. You need $100. Spend the 50 in your wallet. Take $50 from your piggy bank. That's simple. So far, so good?
Okay. Yep.
Now work. You must understand what work means in general. Work does not mean GPE, even though it's joule. It does not mean KE, even though it's joule. Work means the transfer. The transfer. So there is the transfer to the environment also, right? To the environment also. So right now I have to introduce to you the environment. The environment also contains energy in the form of heat, for example. Remember, heat also joule. You learn that. Okay. So it is possible for your piggy bank to drop and your wallet to also drop. I mean, you experience that a lot of times, right? What happened there? There is a transfer of money from your piggy bank and your wallet to the environment. The environment can be the supermarket, can be the owner of a very valuable card, can be the owner of something you have always wanted. For example, iPad. You can go to the store and the transfer happen between your piggy bank and your wallet to the store owner, something like that. Make sense?
Okay. Yeah.
Transfer of money is work. Work can transfer money away from you or into you. I am certain you experience a lot of transfer in your life, correct? From who?
Parents, for example.
Consider parents to be your environment also. So environment can be anything else but your piggy bank and your wallet.
Okay.
And nobody transfer from piggy bank and wallet only. It's usually out or in one. And sometimes from piggy bank to wallet. To be fair, never from wallet to piggy bank also lah, please lah. Right? Also never one lah. Now, this energy work power topic is very interested in the transfer in and transfer out. Not always just the transfer between piggy bank and wallet. Not just like that. Can ya?
Okay.
So transfer in and out. In, out. This one transfer in also. Both transfer, whether internal or external, they call it by the defined term work. Don't ask me why, but that's how they define it. That's how they define it.
So if GPE were go to KE, well, like to be converted to KE,
there is a work.
That's work. Okay.
To convert, that's their word law, to convert. They always say the work to convert. That already tells you that work is a form of transfer. To convert from GPE to KE, there's some work done. Not by you, by gravity, for example. He's falling down. GPE convert to KE. Who's doing the transfer? Gravity lah. Without gravity, we don't have that transfer, for example. That phrases should confuse a lot of people until you think about it. Yeah, it's a transfer and it doesn't happen without gravity. So gravity is doing the transfer involuntarily to you, of course.
Mm.
But the other transfer is usually from your wallet to your environment in the form of heat. So you are moving very fast. Your wallet is full, right? You're moving very fast and you slow down, which is what will happen to us all the time. We run and then we stop. Look, where did the energy go?
It's like converted, right?
You're not running uphill. You know,
Mm.
you're just rolling just kicking the ball. Just kicking a ball. You're playing soccer, you kick the ball will stop eventually. From the moment you kick until the moment the ball stops, the KE steadily drops. Correct?
Yeah.
It is transferring to GPE. It is transferring to where?
It's transferring to heat and
In the environment. Right? The KE disappear. You wish it will continue. You wish it will speed up to the goal. But that's not what's happening now. You kick the ball to the air, he will experience air resistance. After a while, he will slow down. So every KE faced with a resistance from the ground or from the air will transfer some KE to the environment in the form of heat. I hope this makes some sense.
okay.
The transfer is slow but steady until finally no more to transfer. Okay, that's just how our work looks like. That transfer is caused by somebody, somebody's doing the transfer. Can you guess who is causing the transfer? There will be some sort of force one. The transfer from GP to KE is done because there's a gravity force doing the job. The transfer from KE to environment in the form of heat because of what kind of force?
Friction.
Correct, that's it. So if you identified everything already, you have identified there is a transfer, that's work. And you identified who is transferring it. Therefore, this equation will make a lot of sense. Work equals to F times S. The amount transferred, the guy doing the transfer, F, the distance of which the transfer happened. You always need a distance for the transfer to happen. The transfer never happens instantaneously. When you transfer GP to KE, the longer you go, the higher the amount of being transferred. Why? Because the longer or the further distance gravity can act. If you're just dropping for a while, you're not transferring a lot of GPE to KE.
Okay.
If you're just kicking the ball 1 meter from the goal, of course, kick as hard as you can. Nobody should kick slow just because of that. But just kick and the velocity from where you kick until the goal is not very different one. There's very little distance for friction to work. So the transfer is very little, most KE remains. In some sense, some experienced player will just kick as a bit slow near the goal. As long as it goes in one. Who cares? It very fast requires a certain preparation. You actually, that's a very valuable time loss near the goal when the goalkeeper is approaching you very fast. This makes some sense.
Okay.
Okay, so this is the equation I'm introducing. This equation would be new. Look, that's the new thing. This seems to be new, but and again, you know already. That's it. No more new thing. Any questions so far?
No questions.
I've given you the framework. Let's look at some question. Okay. Let's look at some.
Okay, sure.
Ding dong. Where should I be getting? Should be getting it from Google Drive. Okay, to keep it simple, I use the 2019 Pure Physics. I'll be opening it for you first, yeah. So you don't have to. Oh dear, do we have time? Not. Okay, we're done. We're almost done. Okay, I'm gonna share my screen now. Do you see any exam paper in front of you? Yes.
Yep, I see it.
Now, so I just look for what might be, work energy power, right? In MCQ, again, they follow the order of the topic one. So not going to be the first few one. There'll be kinematics and everything, right? So kinematics. Oh, for some reason, there you go. Look at this question for. It's something moving up and moving down, right? First thing first, you notice that? And then he talks about friction. Can you solve this question using your previous knowledge, not the new thing?
Four meters per second. Hmm.
You can write something on a Jamboard, right? Because you have
Okay.
your writing pattern. So if you want to, you can go ahead.
Yeah. So and total amount of energy on this side and total amount of energy on this side, and find the difference, right?
Yeah.
That's what the solution here is doing. But oh, sorry,
What happened?
I pressed undo too many times.
Okay. You can return, I think. You can actually
Yeah, I returned it. This is the part one, so it's 2 kg. Yeah.
2 kg times
And 1, this is 20. This is for GPE 1,
Yeah.
GPE A, and
Yeah,
then GPE B equals to 2 times 1 times 10 times 1.4. Right, and then it says 28. And then it's 28 minus 20, which equals to 8, and then you get this one. This should be number of amount of energy lost.
Now, let me put it this way. You calculate the amount in the piggy bank at A, $20. Piggy bank at B, $28. Right? And you're saying that because your piggy bank increased from 20 to 28, you lose $8. That is already not making any sense at all. Right?
Okay.
But your GPE is fine though. Leave the GPE alone. The GPE is 20 and 28. Nobody say that the working in front of you is correct. Nobody say that. Nobody. That's just somebody else's working, right? However, I think those are the numbers that you need to worry about. But then again, piggy bank increase, but there is some energy loss. It just does not make sense at all.
If I reverse it, can I reverse it? And then 28, and this is minus 8.
Okay, look. Before you go and play with formula, look, your piggy bank increased for 20 to 28. That's not a decrease, that's an increase lah. Call it what it is lah. Your piggy bank increased by
Yeah, okay. Yeah.
Okay, so I'm going to cancel this one. Forget the formula. Your logic is very important at this point. Your piggy bank increased by $8. Is that something that happened normally in real life? Oh, your piggy bank suddenly one day go from 20 to 28. Just
No.
like, okay, so if that happens, if 20 to 20 happens, there must be, you know what? There must be what?
Transaction, like a conversion.
Transfer or conversion. So let's call it a transfer lah. Transfer from where? Remember there are three things: your piggy bank, and then
Wallet, and then environment.
yeah. So if your piggy bank increased for 2028, there must be a transfer from
Wallet
or environment or both.
or environment. Yeah.
Both. So this doesn't make sense unless there's a transfer from. Let's look at the wallet first. Is the wallet being concerned here?
Yes, there is.
The speed is
Speed.
one. The more you say speed, that's your wallet law. Half mv square ma. Your wallet seems to be decreasing. Yeah. That makes some sense, right? My wallet decreased, my GP increased. Yeah. That makes some sense. Let's find out. Let's find out. Okay, initially your wallet is $16 and now your wallet is only $1. Wow, terrible. Did something wrong happen? Did we calculate wrongly? Are you sure this from $16 to $1, your wallet? Just make sure first. Because that seems like a bad deal.
Should be 16 to 1.
Right. So your wallet lost $15, right?
Mm-hmm.
Your piggy bank increased $8. Yeah, good deal.
No.
Something must happen. What?
Oh. Okay.
Something must have happened.
It's the friction then. Right.
Yeah. So during the transfer from, there's a transfer from wallet to piggy bank. I'm pretty sure, right? That one's certain. But during that transfer, there is a transfer out to the environment. How many dollars?
$7.
$7.
Mhm.
Yes. $7 is our how do I say, our transfer . So in the form of physics, we say energy loss to environment is 7 joule. You write the numbers right?
Energy loss to,
right? You say can to environment or to friction, because friction is the guy doing it, right? The guy doing it, right? Is $7. Now remember, whenever there's a transfer, loss is simply a transfer, man. So $7 or 7 joule. Of course, you don't follow me, you think dollars, you write.
yep.
Yeah. But to be fair, thinking in terms of dollar is better than joules, correct or not?
Mm-hmm. I can imagine it better.
Correct. Which is why I'm doing it. So 7 joules, that's fine. Now remember, loss is simply a form of transfer. When you transfer, somebody have to do it. And the transfer itself is called work. So there is a work of 7 joule. What does work mean? Transfer, right?
Yeah.
Why? Because transfer is just easier to understand. Come on, right? Work is 7 joules and somebody else have to do it, which is the friction, you already understand, right? Through a certain distance. Through a certain distance.
Okay.
So if he asks you for friction, I don't think the answer is 8 Newton. Again, yeah? Okay, it's also not going to be 7 joule. First of all, there is no 7 joule here. He's asking for really force. So how are you going to count the friction?
Find distance.
Right. Which is not a very easy thing, right? The friction, the distance, right? The distance is like that. Okay.
2.5 is it? No, because like
that's why they bother to tell you lah. First
Yeah.
of all, it's not 1 meter plus 1.4. It's not 2.4. It's a little bit, you know, it's a bit more than 2.4. 2.4
curve, yeah.
dropped up and dropped down. Okay, or 2.5. Okay, I guess that makes sense. 2.5. So what do you do?
7
Over 2.5.
over 2.5, and then that'll get you
You
2.8.
that is
Okay.
very likely the answer.
Okay, I get it. Okay.
Yeah, this is not considered an easy question. This is medium at the very least. As you can tell, the first guy doing it get it all wrong.
Yeah. I got it. Okay.
The point is, you know why he's wrong. That's the point.
Mm.
If not, you will insist it's 8. You did insist that it is 8 first. You did.
I did insist it.
Okay, clear? That is a good summary of the topic. There'll be many more questions that is more difficult than this, but that's not bad. That's not bad.
Okay.
I mean, to be fair, aren't you ready to deal with some questions? Don't you think? This is from exam. Right? This is from exam. I'll just show you a bit, right? So 9 will be moment, yeah? So probably not. 10 is stability, 11 is probably not, 12 is stability. Stability is part of moment, right? Okay. After that is your pressure. Look at that. Your pressure, right? Okay, 13, 14. Frankly speaking, 14 doesn't look very hard like now. Frankly speaking.
You can just use the formula and then like
I guess as long as pressure equals to pressure, right? Right, and look at that. Okay. Yeah, I mean whatever lah. You can give it a try. And then thermocouple is the next chapter already. That will be the heat chapter, right? Heat chapter. So not gonna bother about that right now. Going to section B. Look at that. Section B, your kinematics, right? Kinematics, right? This must be power. This must be some sort of pressure, right? Must be, right? Then this looks like moment, right? Looks like moment. Pivot and all. This looks like pressure, right? This looks like, oh, that's heat transfer. So a heat chapter. This is line. Oh goodness me, he's not gonna give you any work energy power. Really? Really? Oh, this is acceleration, speed, ignoring air resistance, deceleration. This is similar, right, to what you're doing just now. They give you a this, right? Okay, that's for this is heat because temperature, and oh goodness me, this
electricity.
Give you any of the
Faraday's law. What's that?
This is year 4. Electricity. Electricity, right? If you like it, then good for you. That's one of the most interesting one according to me. Very modern, but wow, this paper doesn't give you anything except for that one. Okay, sure thing. We can talk about it in another paper. Now, for now, 3:30. You okay so far?
Okay. Yep.
Then I'll see you tomorrow. We either continue with physics or chem, either one.
Okay, sure. I think it depends if Aiden comes. If Aiden comes, I think we can continue with chem. I don't know if.
Oh, his chem is advanced, but he's catching up with.
Okay, then
But the point is, energy work power, if I give you an exam paper, exam paper question, it is almost certain you can do something already. You have enough information already. You check it out. Okay.
Okay.
I will see you tomorrow. Bye-bye.
Okay. Bye bye. Thank you.